चाहते दूसरी वाली ये भूल जाती है कि इतना फैसिलिटी वो जोड़ ले हटा देती है, माँ बाप का इंश्योरेंस, इसके बाद उसका इंश्योरेंस है, जॉइनिंग बोनस दूसरी वाला वो नहीं पूछ सकते हैं।
भाई मुझे नहीं समझ आ रहा। ठीक है।
போதுமா நேரம் தொழுக போகணும்னு சொன்னேனே இல்ல இதெல்லாம் உனக்கு பிளைன்ல கொடுத்ததா
ఇంత గుర్తుంది ఏంద్రా ఈ ఎవరితో ఎన్నికల ప్రాబ్లమ్ సాల్వ్ అవుతుంది రోజు రోజుకి
Hello, everyone. Good evening. Okay. String concatenation is now working fine on portal. Okay, chalo, thanks. That's a good update. Okay. Just a second.
ଯଦି ମତେ ତମ ଖୁସିରେ ଖୁସି ନ ଲାଗନ୍ତା ମୁଁ ତମ ପାଇଁ ସବୁବେଳେ କରିବାକୁ ଚିନ୍ତା କରନ୍ତି ଏବେ କରିବାକୁ ଚିନ୍ତା କରୁନି ତାର କାରଣ ହେଉଛି ମୋ ପାଖରେ ନାହିଁ ବୋଲି
Okay. Hello, everyone. Good evening. I think we can start. So today I think we'll be discussing first. Let's complete strings. Okay, let's complete a few more questions on strings so that we spend a little bit more time. I would be needing okay, 1 hour will take for sorting. So just give you one idea. We'll start with by writing like some basic algorithm today, and later we'll optimize it, right? So later, or we'll write optimal sorting algorithms. We'll try to see what are the sorting algorithms, what's the complexity, how do you optimize it, what things, what sorting algorithms can we learn now, right? But we'll see about sorting. Okay. So let's start quickly. Okay. So. Achha, my name is changed or not renamed my name. Okay, let me rename it. Yeah, that's fine. Okay, we have triplets. We have array list question, triplets sum in array list. That is one question that you all have asked, right, to do it. So one is triplet sum to XTK. So this is one question we'll do. Let's start on string. So okay, so string, all the concepts I gave you. Okay. Now, okay. Any doubts in string question? What are the doubts on string questions? Did you try completed? What's the doubt? So I guess one would be piecewise. This would be one doubt. Another would be panagrams, maximum frequency. These all things I have told you how to use. Good string. Okay, good string is one. So good string is also same concept. Okay. Good string, panagrams, all substrings have a string. So this is easy. All substring is the easy one.
Sir,
Yes.
sir, I have a small doubt, sir.
Same.
I just copy a coding portion in the chat.
Is it from assignment or is it from Zim?
Assignment question, sir.
Okay.
In the keyboard.
Keyboard. Is it there in string 2?
1 second, sir.
Word from keyboard. This one, right?
Yeah, yes.
Okay. Okay. So
So actually, in this contains function is only works on strings, sir, or because initially I put s dot caret j, but it didn't work there. So I add an empty string. That time it works.
okay, so you can okay, so basically it takes an string as argument. So when you pass the character, it is not character to string is not an automatic conversion, right? In when you do string concatenation, everything gets converted to string in that's happen automatically. But when you try to do it character to string, that is like a complete conversion. So you're creating a new string, right? So that's why it is like we should not be using this inbuilt function too much, because if for example you just want to check for a single character, right? Now what we are doing is we are using a contains which is creating a string. Now you create a string, you check that string. That is like too much additional work. You could have simply written a for loop that would iterate through this string and a string, and that will tell you whether the character is present or not. That which is exactly equal to the complexity that you would get in here, and that is a better solution because you won't be creating strings again and again since you're comparing only one character.
Yeah, okay.
Hold on. Okay. Except R string. Okay, chalo, that's good going. So I see like comparatively, I'm seeing lesser number of doubts. I guess string is something which you all are understanding. String is not very much difficult. Okay, chalo. Let's start. So let's pick few questions. Let's discuss them. So camel case, toggle character, inverse camel case, compressed string. Distinct palindromic substring. This one. Okay. This is one. Okay, this is marked as out. Let's see anything else. Supple string, palindromic string, count words in a string, all string, panagram, good string. Okay, good string was one doubt, right? So these are two doubts that I got in chat, right? If you don't say, I'll pick this two. Any other doubts? That's here. Minute time will try to. Okay, chalo. Okay, so let me explain this. I'll explain the question. Then you can try. Okay, and okay, if you all are following, if it is getting solved. So see, if you are seeing, like if you are able to figure out the solutions, I'll give you hints that you can use to solve this, and we can start with sorting, or we can go to the array list, complete the doubts that's there in array list. I guess there is only one question that's there, right? Okay, so I'll complete that. If you still have doubts, face issues, we'll use another class, right, to solve this. Don't worry. Okay, so distinct palindromic substrings, right? So what does this question say? That we are given a string S and we have to print all the substring S that are palindromic. Now, what does palindromic mean? That the string reads both same forward and reverse. Okay. Now, how do we find out a palindromic substring? How do we actually get a palindromic substring? So firstly, let's say we want to simply write a logic that would check whether a string is palindrome or not. Now, how would you check a string is palindrome or not? There are a lot of ways. One is you can find out the reverse of the string. Okay. One way is to find out the reverse. So you let's say have ABC, you find out the reverse, which is CBA. Okay. I also told you another way while in case of arrays or in case of so in case of numbers, it's not possible. You will basically need to find the reverse of the number and then only you can check. But in case of arrays, this second logic was possible. How will you check whether a given array is palindrome or not? Yes. So you'll compare the two characters. So let's say you have two values. Let's say 8, 2, 1, 3, 2. So what you'll do is you will start with 2 pointers. One pointer is pointing to X, other pointer is pointing to Y. Okay. Now what you do is you just compare these 2 pointers. So this X and this Y. If they are equal, then you go to the next character. X moves to here, Y moves to here. Okay. Now you compare these 2 characters. Okay, you compare these two. If they are not equal, then it cannot be palindromic string. Because why I am telling it is not a palindromic string? Okay, let's look how this looks like. So this is the string that it looks like. When you actually do the reverse, what you are doing is you are putting the last character at the start, second last character at the second position, third last character at the third position, fourth last character at the fourth position, fifth last at the fifth position, first character at the end. So basically, when you're comparing first character with the last character, second character with the second last, third with the third last, fourth with the fourth last, and so on. Now you don't even need to find out this reverse. You can simply start by comparing from here. Right? Until when you need to compare now? Tell me what should be the condition till when you need to compare. If let's say this is X, this is Y. So first iteration X goes to here, after Y goes to here. Until X is less than equals to Y, you can need to compare it, right? Or X is less than Y, because equals to case mein, you don't even need to compare. Until X start is less than equals to end or start is less than end, you need to compare it. Same goes over here. In case of string, you can keep 2 pointer. One it at the start of the string at the index 0, other it at the last character, which is index n-1. You can keep on comparing until you get a mismatch character. If like all the characters compare, then it is like the correct thing. Okay, then it is a palindrome. Okay, so now this would tell whether it is a palindrome string or not. Okay, you will get the palindromic string. Now, what else is asked in this question? Okay, so first question was to find out palindrome, that we got. Okay, second thing is print all the substrings that are palindromic. Acha, did we solve one question or did we discuss about one question that was there over here, which told us to print all the substrings of a string? Did you solve this question? Did you solve this question where you are asked to find out all the substrings of a string? No. How do you find out all the substring? Not using substring. See, try to use the least number of functions on string as possible. Reason being, string is one such topic that interviewer asks you to write those functions yourself. Okay, so interviewer expects you to write those functions. If you are appearing for like SD2 or senior engineer level, then interviewer won't ask you. But if you are appearing for a fresher engineer, right, then interviewers ask you to implement those functions. Even at senior levels also, they ask how this function would be implemented if I ask you to implement it yourself. Right, so don't rely too much of functions, because these functions are very simple logic. Okay, so for example, if you are doing substring, we saw that is a very simple logic. So interviewer can ask you definitely how to find that substring yourself. Okay, so okay, now okay, we have discussed one concept of subarray, right? In the subarray concept, what I told you, let's say this is an array, and you were asked to print all the subarrays of this array. So let's say this is 1, 2, 3, 4, 5. These are the values that's present. So how do you start? You start with the first index and your ending index is here. So you say this is your subarray I to j, which is 1. Then you change the ending index, your j becomes this, and you say the subarray is 1 to 2. Then you change this, it comes to here, and your subarray is 1, 2, 3. Then you change this, it comes to here, and your subarray is 1, 2, 3, 4. Then you change it to here, it becomes here, and now the subarray is 1, 2, 3, 4, 5. Right? Okay. Okay. So these are all the subarrays that start with 1. Now, is it all the subarrays? No. There are even more subarrays which start with 2, right? So we then change the first index, which is here, and then we start with 2. Now 2 and ending index is 2. So that is the first subarray. Now we change it here. So that becomes 2, 3. Then 2, 3, 4, 2, 3, 4, 5. Now you can use the same logic in string, right? I told you, just think it like string. An array, like just think it like an array. That's done. So now if you have ABC, what are your subarrays? You have A, then you have AB, then you have ABC. Okay, then you have B, then you have BC, and then finally C. These are all the subarrays that you have. Okay, that's the result. 3 loops. Yes. Now, first subarray, second would point out. So it can be done using 2 as well, right? You don't need 3. It can be done using 2 loops, but the complexity would be n cube, right? The complexity is n cube, but it can be done using 2 loops. So n cube is fine, right? 280. So see, the string length is 280. So 280 is 280 into 280 into 280 n cube, which should be fine. How do? Yes. Lexicographical order, since we have today sorting, I'll talk about that. I'll talk about the order. It is not asked in any lexicographical order. So let me solve this. So let's solve this one. Okay. So let's say we have a string. What we are asked to do is we are asked to print all the substrings. So similar to this, this is going to be the start index. Start index is going to vary from 0 to the length of the string, right? As dot length. The start index is going to vary from 0 to length, I plus plus. Achha. How is the end index going to vary? So end index is going to vary from I to less than n. Okay. I to less than n. So for the first string, every time you do this, you start with a new start index. We start with a new string. Result is equals to empty. And what we can do over here is result is equals to result plus s dot char at j. Okay. Done. Okay. After every concatenation, we'll get a new substring. So we can print it over here. System dot out dot println result. After every concatenation, the string formed is a new string. So we can basically concatenate it to get the new substring. Now if I run this, two loops and n cube complexity. Okay. Now we are seeing all the like strings. What's the complexity of this one? What's the complexity of this logic? So n square dikh raha hai, right? It is n square. And sab bhul gaye. Everyone forgot this, what I told yesterday about strings. No one remembers?
Because of concatenation, sir, order of n.
So this concatenation operation is n square, right? Sorry, n order n. This concatenation operation is order n. Now see, why do I tell you to avoid substring? Okay, why do I tell you to avoid substring? What's the complexity of substring function? Substring is n square, right? Okay, so I'll talk about this. Firstly, let me do a dry run so that you all see how this is working. See, so firstly, I have I equals to 0 and j is equals to I, right? First iteration. Our result is an empty string. Our result is equals to an empty string. Okay, it is empty string. Now what we do is we do an empty string plus the character at j, which is 0. So we do empty string plus character at j is a. So this becomes a as a string. Now we print it, so we see a as output. Okay. Next iteration, j becomes 1. We now this is having a as a string. We add the b character, so it becomes ab as a string. We print ab. Next iteration, j becomes 2. We add a c as a character, and it becomes abc as a string. So we print this abc. Okay. Now, okay. So we got this. Next, j will become 3. The condition will not be true. String length is 3, so this won't satisfy. We break this. We come out of this loop. We go to this loop, and we increase I, which becomes 1. Okay. Now again, we'll go to the j loop. Now see. So this is done. We got ABC, and then finally again we'll go back to here. Now here we'll do this. We'll again start with j equals to 1. Our string is empty string. Now this time we are firstly adding s dot caret j, which is b. We add b, so it becomes b as a string. Say print b. Next iteration j becomes 2. We add c to this, so it becomes bc. Right? That's what we are printing over here. And finally, like this will become 3. This again terminates, and for the last iteration, only c is going to get added to the string, so it becomes c as a string. So here see how it is n cube, because these two operations are order n, but this operation is also an order n operation. This is a on operation. This is not a o1 operation. So string concatenation, like number addition, it is not working, right? It doesn't work like number addition. So number addition was a o1 operation, but string addition is not a O1 operation, it is a order n operation, right? So this makes the entire complexity as n cube. Now, why do I always say you to avoid string function C? Here you can miss this very easily. That okay, you'd see, oh, I'll need to find out the substring, right? And I need to print it. So what you can do is, instead of doing the string concatenation, if you just do this substring, and let's call it as to pass the indexes, starting index is I and ending index is j plus 1, right? So you just like this is not included, so you pass that from I need the character from I to j, right? Now tell me, what's the complexity of this thing? What's the complexity of this one? No, this is not n cube. This is n to the power 4, because string, this substring function is n square. So this is n square, and these two things are again order n. So this becomes n to the power 4, right? Let me show you this. We did this yesterday. Okay, so let me show you this.
Sir, I comma j hoga.
No, it's j plus 1 because that index is not included, right? So जो second parameter होता है ना, so if I pass 0 to 1, so वो 0 वाला substring return करता है. Okay. चलो मैं example दिखाता हूँ. Let me show you that. So let's say this is substring, right? So यहाँ पे मैंने क्या बताया था? How does substring function work? How does substring give you the substring actually? So let's say what we are doing here is we are finding out a substring till k index. So how do we find out a substring, right? How can we find out a substring? We'll do a empty string. We'll start by concatenation and we'll run this loop to find out that k characters, right? So this operation is resulting in a n square logic. This is a n square logic. Now same thing is done by the substring function, which makes the substring function n square. So if we pass it 0 to 3, it actually gives us. Now on that doubt, why do I pass it one additional? So see, if you pass it 0 to 3, it is going to give you index 0, 1, 2. Okay. Okay, so this last index is not included. It is one less than that. Okay, so we are getting 0, 1, 2. That's why you always have to pass this one greater than that. Okay. So if our I and j are equal, we have to run that loop. So we'll do that. Okay. Now see, this substring looks like a simple operation, but see the how it increases the complexity from n cube to n to the power 4, right? So that's why avoid using this. Right? Write this substring logic yourself. So now here, how we are getting n cube, because this operation is order n. Concatenation is order n. Now substring had a different logic of performing concatenation. It didn't know that just we are adding one character. It will try to go to add like it is not adding one character, it's trying to go to the again string and finding out from I to j, which makes it n to the power 4. So this one is better, and that's why this constant is given as 280, because you can't optimize it for more than this, right? This is the most optimal solution that you can get, and which is 280 into 280. So let's consider for simplicity 300 into 300 into 300. Okay, so it is 9 into 10 to the power 6, right? Which is fine. 9 into 10 to the power 6 almost roughly equals to, if I say 10 to the power 7, which is very well fine within the constants of 10 to the power 8. Yes, we will use string builder just to overcome this problem, right? So this is one very major operation that we need, concatenation, right? So adding something at the end. So this is something which we cannot get in string. Same like array, right? Array में operation नहीं हो सकता in O1. In array also this operation is order n, right? What's the complexity of this operation in array? If I tell you to add one new number at the end of the array, how can you do it? Is there any way you can add a new number to the end of the array? Can anyone think of a solution? कैसे सोच सकते हो? How will you add a new number to the end of array? Think about how ArrayList does it.
Yeah, create a new array and.
So you create a new array, you copy all the existing numbers, and then you like add that new number, right? So that is order n, right? Same thing if I ask you to do in array, if like there is already an array, and then you try to create a new array. So what you you try to add a new number. So what you can do is, the only way to add this new number is you create a new array, copy all the numbers that's there in this array, and then add that new number at the end. Okay. And finally, you point the, let's say this was the A reference that was pointing to this array. Now you remove this, A will now point to this array, right? A is the reference will point to this array, and this would get garbage collected. Okay. And same thing we are doing over here, right? The string concatenation. use array list, then also it is n cube. Array list is different, right? Array list we understood why adding it at the end is O1, right? So same operation in array list was O1, right? If I add one number at the end of array list, it was O1. This a dot add operation in array list, this was O1. Why it was O1? We understood that logic, right? It actually has some extra space at the end of it. Every time there are only very few operations where it doesn't have, and that time it manages it. But apart from that, all like 99% of operations have extra space at the end, so it just uses that space. Do we have extra space at the end of strings? No. Let's say we cannot do it on string. Okay. Understood. See, time is very close to memory, right? If you understand this memory, like, so you will easily understand that why time is this, why it is taking this much time, why can't we optimize that? Okay. So but created this constant, he thought, right, what can be the largest size that we can get without error? So he thought 280 can be possibly, and without that, like we cannot optimize this code beyond this. So this is the most optimal code, and we'll get only till 280 size of string we can find out all the substrings. See, so costly operation. So how costly this substring finding is, right? So it's double its size or using the same calculation capacity. It doubles its, so for example, here, in case of string, there is no double up, right? So in case of string, it doesn't double any size, it doesn't have any extra buffer. Same like array. Array, there was no buffer, there is no extra space that's there at the end of array, so we cannot add anything to the end. Its size is fixed, we cannot do anything, we cannot alter its size in any way. If we have to anyways, let's say store something at end, we ourselves create. In case of array list, yes, it doubles up. It has that extra space, right? So most of the time it will always have that extra space. So it starts with 10 and then it always doubles up, right? So when you're adding the 11th element, it would double up, and then it will create an array of 20 size. Now for 12, 13, 14, 15, 16, 17, all those elements can be easily added in O1 space because you have that space with you, right? You already have. So if you already have that space, you can access any array space in O1 time, and you can perform any updation or reading what's the value there, all those operations in O1 time. Okay. Can we compare and find if three variables which the greater or two variables are equal? In 2 to 3 lines, maybe ternary operator, but that would be very much nested for 3 values, right? For 3 values, if you just want to check it with ternary operator, it can be done, but it would be like too many ternary operators in a single line, right? So that again is not a single statement, that would be internally broken down into multiple compile statements. Compile, it deletes the space. Garbage collector would delete the space and it will make it available for other variables or other arrays or anything. A copy of her copy is order n if no copy and one. I did not get that moment. What's the second part? Copy is order n. Yeah, that's fine. Which is empty in array list. Achha, no. It won't. The empty part doesn't get garbage collector, right? So empty part doesn't get it. Always keeps that additional buffer. If it has created that array list, it would keep that no matter we are using it, we are not using it, doesn't matter to it. Okay. If copy, then it is order n. If no copy, then it is order 1. But the copy operations are very few. So I'll recap the array list part. I guess you all have doubts there. So we'll recap that. Okay. Okay. So okay, let's talk about this now. So we saw we can find out how we can find out substring, how we in the optimal way, how we can check whether a string is palindrome or not. Now what else is required to do? So you have to print all of them in the lexicographical order. Okay. So finally this is done. So you have to put all of them in an array and you have to print them in the lexicographical order. So here also the same size is there. Size is 1000, right? Here it is 10 to the power 3. So okay, no, it is okay, so its optimal solution is only by string builder. I don't see there is any other optimal solution that you can get. So it is using string builder, it is n cube again. I guess it is n cube, or there can be some way to optimize it to n square, but I don't see right away. Chalo, we'll check. Okay, let's first find out the solution. Okay. So, okay. So what are the things that you need to do over here? So I'll not explain this today. I'll not write the code. I'll just give you idea, right? So first is to find out whether string is palindrome or not in optimal way, right? Can you do it? I told you, right? You don't need to create that string. Like you just can use the current string to check whether it is palindrome or not by using X and Y. Okay. Next part, let's say you figured out whether it is palindrome or not. You have to do it for all the substrings. Can you do it for all the substrings? Yes, we just saw how we can find out all the substrings. So you can definitely find all the substrings. Now, last thing is how will you sort a string, right? Print it in the lexicographical order. It simply means string sorting. Lexicographical order is simply means you have to sort the string. Okay. Now, how does string sorting work, or what is string sorting all about, or what is sorting? Okay, that we'll see today. So probably that will fix all the doubts that you have. Okay, so you already know these two parts. Only this part is remaining. So that will cover today. N cube should be fine. N cube, this should be accepting it, but since it is it will be accepting it. I don't doubt it won't accept. But I guess since it has given the constant, I was thinking if we can optimize, and I'm not seeing right now any solution that is better than n cube. I know that string is order n cube and make it n square. No, I don't see any solution better than n cube, right? So I guess either the constant is mentioned incorrectly, or I am not able to figure out that solution right now. But I remember last time also we did it using n cube logic. Chalo, I'll think, right? And you can also parallelly think n cube is possible. N cube is possible. If you do it using strings, you might even get n to the power 4. But yeah, using string builder, it will reduce to n cube. Okay. N cube is fine. Yes. N cube would work. It would get submitted as well. String sorting, there is a few more things to consider. So there is a separate class that's after like sorting in, and that's for string builder. So I'll give you an idea today about string builder. So we'll cover that and we'll use that class for sorting. Okay, so don't worry. Now, good strings. Did this question is complete, or you have doubts on this one? Okay, so now try this one. I gave you like hints how to find out substrings that we solved, right? I told you how you can check for palindrome. Now you can do it. Okay, if you're done, then that's great, right? Chalo, that's great. Okay, others, please try this question, string palindrome. I'll give you more hints today, right? We'll understand sorting, so you'll probably get more idea about it. Okay, now what's this good strings? So we are given a string S of distinct character. We are also given an array N, and we have to find whether the strings are good or not. It is good if all the characters in the string is present in the subset S. Okay. Now tell me, did you all complete this? Is this done, or there is doubt still? I gave you the concept, so let me write the code for this. So this one I can help.
Sir,
Yes.
so the palindrome question was throwing some runtime error for a very long input.
Palindrome question.
This is the normal palindrome one.
So let's check this one. We just
So I tried using char array also, but then also that test case was not passing.
So here you don't need to. So we are having a string and we just need to check it is palindrome or not, right? So we don't need to find substring. I guess you are finding the substring.
No, sir, I tried both. Whether like converting it to char array and that one which you just told right now.
Chalo, let's see. So we can go with start and is equal to s dot length minus 1. S is less than E. Okay, this is the condition. Let's check if there is any other thing. So it is telling race car is not a palindromic. It is 0. It is not a palindrome. R matches with R. A matches with A. C matches with C. E doesn't match with A. Okay. A matches with A. M matches with M. A matches with A. N matches with N. Then we have comma. Okay, comma, spaces, all these special characters we don't have to consider while comparing it. So we just have to consider the characters. Okay, it has mentioned here. Determine if it is palindrome only by considering only alphabet characters and ignoring the upper or lower case. Okay, so we have to only consider alphabets. We don't have to consider their cases. And return 0 if it is not a palindrome, else return 1. Okay, So see, one thing you can do is before like doing this entire comparison or writing any entire logic, the best solution is to firstly convert this entire string into a lowercase string. So you can do s dot to lowercase. Okay, so this will convert it, right? I gave you this function that you can use to convert this entire string to a lowercase string. So you don't have to check that, right? If you don't do it, you'll have to additionally check whether character is capital or small. Now, if the character is capital, you convert it into small character and then check that small character. If the character is small, you convert it into capital, right? Either ways you can handle it. I just converted the entire string into smaller case, so I don't have to deal with that mess, right? Don't have to deal with that if else check. Now, if the s is less than e, okay, we'll continue. If s dot char at, sorry, so this is start, right? And this is end. Let's call it start and end. If s dot char at start is not equals to s dot char at end, then you can return minus, then we can return 0. And otherwise we can return 1 if all of them match. There is only one catch. We don't have to do this checks for spaces and all the things. So if s dot char at I, this is greater than equals to 65. Oh, sorry, we have converted to lowercase, right? So greater than equals to 97 and, or let's say you can check it for this, greater than equals to small a and s dot char at, sorry, I caret start is equal to this and caret start is less than equals to z. If this is the situation, then we are fine, right? If it is within this, then it is fine. If it is not this, if this condition is false, right, then what we have to do? If this condition is false, then we simply move the start forward. And we do the same thing for the this part, right? We do the same thing exactly for the end part. See, why did I put a not? And this is like one of the very good use case of not, where I'm checking whether it is easier to check whether it is within this range or not instead of writing the alternative condition. So I wrote the condition exactly of how I will check whether it is in the range of A to Z or not. Okay. If this condition is false, that means it is not in the range of this. So in that situation, what I have to do is I've simply moved start by 1. If this is if let's say this is within range, we get this as true. Like this tells that s dot char at I is within the range of A to Z. So this condition will be true. So we mark true, not of true is false. So we don't run this. We check for the else. We check for the end part. If end character is a valid character, then it's fine. If it is not valid, then we increase the end as well. So we can do end plus plus. Then finally, if this okay, if we did this, we'll go to the else part. If both of them are valid characters and if they are not equal, then we return simply 0. Okay, if they are not equal, then we'll simply return 0. Otherwise, we return -1. Okay, sorry, and minus. Okay. Now let's check. Let me just do a quick check. Okay, there are multiple ways to write this condition. You can write this is less than this is less than this. You can increase, decrease. You can. So I'll not suggest to creating a new string. If you are creating a new string, ignoring this character, I don't think you should ideally be doing that. What else missing? In case this is not equal, otherwise we can do a start. Okay. If else, we can go to else. If this is equal, then we increase both. Increase and decrease both. Run this. Because we get 0, which is fine. So since this is not a palindromic string, for this we should be getting a palindromic string. So let's copy this. Let's post it over here. Okay, we get 1. Okay. Now let me explain what I did over here. See, it has told us to check for same logic that we did earlier. We'll have a 1 pointer at the start. We'll have 1 pointer at the end, and we'll compare both of them. Just explain. दीदी मम्मी का कॉल आ रहा है, बात कर लो. Okay, sorry. Yeah. So now we did two same logic. We have one pointer at the start, one pointer at the end. Now what we are doing over here is we are comparing these two, right? So let's say 0 and n-1, we are comparing, but we'll only compare them if both of them are character. If any one of them is not a character. So for example, let's check this example. Okay, let's check for this example, which is like the one will explain everything. We have start over here and we have end over here. We'll compare both of them. Both of them are valid characters. So we'll say, okay, is start greater than s equals to a? Yes, it is. And it is less than z? Yes. So and this is true and true. So true and true is true. So what is not of true? False. So it means that this is in the range. I don't want to do this operation. When it is in the range, I don't want to simply move start. We simply check again for the end as well. Is end in the range? So is end greater than equals to a? Yes, it is greater than equals to a. Is it less than n? Yes. So this is within the range. So this would do true, and I am just doing not of it. So it will make it false. So I don't want to do this as well. Now, is both the characters not equal? Now, this is the first time I'm comparing both the characters. When I'm comparing, when both of them are valid characters, right? So when both of them are valid lowercase alphabets, then I am comparing them. If any one of them were not valid characters, that I'll see, right? We'll see what would happen in that case. So now we are comparing them. If they are, is that not equal? No, they are equal. So this also doesn't satisfy. We go to the else part. Now, what we do at the final else part? In the final else, we have just increased the start and decreased the end. Okay, so now it would just move the start by 1 and end by 1. Okay, now see, start and end, both of them, start is pointing to the second index, end is pointing to the second last. End is a valid character which we can compare, but start is not a valid compare, right? Start is not a valid compare. We don't want to compare this particular character with M, right? We need to compare the next character. So what we are doing over here, check. So is space greater than equals to a and less than equals to z? No, space doesn't satisfy this condition. It is not in the range of a to z. It is in a different character, so it is in a different range. So it doesn't satisfy this. So what would happen? This would return false, and this would also return false. If one of them even returns true, doesn't matter. Any one of them is going to be false, and this would return final result is false. What is not a false? Not a false is true. So we would change it to true. Final result is true. So since we have done a not of it. Now, since this is true, we go to this if part, we simply increase start. So start would come from here to here. Okay. Now we don't run this else part, we don't run this else if part, we don't run this else if part, we go to the next iteration. So see what happened, end actually remained there and start actually incremented by 1. So we moved the start by 1, end actually remained there. And now we'll compare the character that is valid with the valid character, same like whatever we did earlier. And now since both of them are equal, we'll move start and end both of them forward. Now, if any one of the time start becomes where to use else part, so this is getting used, right? If both the characters are equal, then none of these conditions are going to satisfy. See, for example, here, right? This is pointing to second. So first case was that. Now this is pointing to M and this is also pointing to M. Okay. See, now this is also pointing to M. This is also pointing to M. So what is going to happen? Start is pointing to here, end is pointing to here. Now check for this, what is going to happen, right? Check for this. And for those who did not get it, just listen to this condition, you'll understand this. So now start is pointing to M and end is pointing to M. So what we are doing over here, we are checking, is M greater than equals to A? Yes, this is true. And M less than equals to Z? Yes, this is also true. Both of them are true. If you compare them by ASCII values, you are going to get true, right? Whatever ASCII value of M is, it is going to lie between 97 to 122, which is fine, right? So it will be correct. So what we are doing in this case, see, so both these conditions return true, right? First and the second condition, both of them are true. So we check true and true, which is true. So not of true is false. So we don't enter this if. Okay? So if it is in the range, we don't do this operation. Same goes for end. We'll check M. M is not again in the range. So this also will get true and true. And we'll get the final result is true, but we have done a not of it. So it becomes false. So we don't do anything over here as well. Now, finally, we go to the else if wala part, and what we are doing over here is we are checking is M not equals to M. No, they are equal. So this not equals to condition also doesn't satisfy. So we don't even go to this else if part. If they are not equal, then we can right away pause and tell that we are done with the function. This is not a palindromic string. We can return 0. But if we have, like, if the characters are equal, then we can keep on continuing our checks, right? So we'll continue checking whether it is palindrome or not. So here we got, okay, they are not equal. So we'll say, okay, let's return 0. But here it is, this condition doesn't satisfy, they are equal. So now we'll go to the else part, and what we'll do is we'll move the start by 1 and the end by 1. Okay. So when they are equal, we'll just so else part is getting executed most of the time if I give it a string like MADM, which is not having any special character, which has just simple characters. So only else part will get executed if it is palindromic. Right? If it is not a palindromic string, let's say A, B, C, X, Y, Z, something like that. So this first character, last character match will this not equal will satisfy and will simply return 0. That first and last character doesn't match. So there is no chance of this string being palindrome. So we can simply return 0. This is not a palindrome string. Okay, understood? Clear, clear. Easy. Okay. See, even if you don't put here equal to it, it doesn't matter. It's not going to matter because see, for start equals to end, this condition is anyways true, right? Start equals to end. So you're comparing the same character, right? So it is anyways going to be fine. Whatever be the other conditions, right? If you put it equal, that's fine. If you don't put it, that's also fine, right? Okay, done. Understood? Palindromic check. No, we can't do it without else. Why I did not do it without else? Because see, I am updating it over here as well, right? So when this update happens, I don't want to want it to update again. So that's why I put it in the else part. Only one of these, all these 4 conditions, only one of them is I want them to run, and I've written it in the such a order that if one of them is true, I don't want any other to run, right? So if I let's say I have increased start plus plus, I don't want this to happen because in this iteration we are not going to compare start and end, right? So that's why I told that okay, let's skip this. Can we reverse the string? See, here you are getting a complexity of order n, right? What's the complexity over here? We are not doing any string concatenation. All these operations are O1, right? So final complexity is order n. Your final complexity of this logic is order n. But if you try to find out the reverse string, your complexity will become n square. And using string, you cannot optimize it. You can optimize it within using like string builder, but not using string. Okay, I'll explain. Okay. How many of you did this question by creating the new string? That I guess would get accepted. So this is order n. Lowercase is order n. Now that's an interesting thing. Lowercase should be order n, but if it is order n, then it is concatenation. It would be n square. No, it's not order n. It would be n square. Okay. Okay, but that you can handle again inside using if else checks. Okay. Can you use? Can we do it without using 2 lowercase? Actually, we can do it. Okay. So we, if you feel like we can remove this, we can actually remove it. Yes. See. So let's do it without using this. Okay. So let's say we have 2 characters. Okay. Char C, which is s dot caret start. Okay. And char ch, let's call it as C1 and C2, which is s dot caret end. So this is C1. This is C2. This is C1. This is C2. This is C1. And this is C2. Okay. I just updated all the references to them. Now what I need to do is I just have to ensure both of them are lowercase, right? So if C1 is greater than equals to A and C1 is less than equals to Z, then we are fine. But if it is not in this range, if it is, let's do it in this way. If this is equals to capital A and this is equals to capital Z, okay, let's do it in this way. So now it is capital, we just have to convert it into lowercase. How do we convert any capital character into lowercase? By adding 32. Okay, same thing you can do it for C2. So now this character would also get converted to lowercase. Done. Done. So this, now we did the same conversion. Since we have to do it for only one character at any point of time, we don't have to find out the entire string. This is a constant operation. This is not even order n or anything. This is a constant operation, right? Just finding or reading a character from string is a constant operation, and now we are doing all this. This is also a constant operation. Now, if I run this, if I submit this, should be fine. To lowercase, I think it should be order n square, but I guess it is order n. So let's check. Okay, I'm not sure whether it is. Okay, did I do something? Compilation error. Okay, there is a compilation error. Let's check what's the compilation error over here. Is it n square? Anyone verified it? Okay, this is square. Can anyone Google up and verify simply? Order n? Okay. Then it is order n. Then that's not a problem. Okay. Then we'll have to look at the implementation because it won't be using the string concatenation to find out the new string. Forgot the brackets again. Okay. Okay. Done. We got this as 0. Oh, this should be 1, right? Now what did I do wrong? Correct that to this guy. This is the, if this is in this range, we convert it into this. C2, we compared it, C2, and we are updating C2, C1, C1, we compared C1, C1. No, it's not. So we have checked, right? It will only, we will only do plus 32 because if it is in this range, right? If it is in the range of capital characters, we'll add 32. But if it is in the range of small characters, we won't do anything, right? If it, let's say this is a small character, we won't do anything. If it is a small character, we won't do anything for this as well. Okay. What else did we do wrong? Greater than the. Okay, here, right? So here it would be C1. This is C1 not equal to yes. So now let's check it. Okay, there was just a like mistake over here. I guess that should be fine. C2 also. Oh, yeah. Okay, now we got 1. Now if we submit it, we're getting fine. Okay, now that's debatable. So let's look, right? Actually, I'm also not very much sure how this is going to work, right? I remember it is n order n, but now thinking of the implementation, it looks like n square. Okay, lowercase Java string complexity. Okay. This would have a better solution. So we'll look into this, how this is doing if it is order n, but I don't think it is. Okay, it is saying that it is using the same reference it is doing, but then how is it updating, right? So there should be something, right? Implementation wise, it might look like n square, right? If you try to actually implement it yourself, it would be n square, and we can't get anything better than that. Okay, so I'll look into that. What's that complexity? See, one thing I always say is try to avoid the string functions as much as you can. So there is one way, like it can use internally a string builder and then return your string. Okay, that's completely fine. So basically what can be done is your string builder can be converted back into string. So you do all the operation in string builder and then you convert it back into string. So that would be a order n. Okay, so that is fine. If it is doing that, that's fine. But without using string builder, but just by using strings, it might not be possible to get order n by into lowercase, right? Because a string concatenation would take order n itself. So that itself is an order n operation. Now, since strings are constants, we cannot edit them, right? So that you like given all the constant, string is something which we cannot update. String is concatenation is order n. Now, how will we create two lowercase in order n? That is a good question without using string builder or something else. So see, the best thing is to use the lesser number of string functions as possible, or don't even use them at all. Okay, because in interviews, interviewer are very cunning. They will ask you to do these things. Okay, so these are even there in the interviewer docs. I have seen those docs. So it is even so whenever an interviewer interviews you for a company, there is a list of guidelines that is given to him, right? What are the things that he should be looking for? What is the question that we should be asked? So this is there in the example itself, that if if a person is candidate is using string functions, try to ask him questions like, can we do it without string function? Is there any possible way we can write this function ourselves, right? Whatever possible thing that it is string. So interviewers generally ask this question in interviews, that if you write a string function, it would immediately say, can we do it without by removing this logic? Can you write this logic yourself? So let's say you use two lowercase and you did not write this logic and you wrote the entire code. Now the interviewer would ask you, can you do it by writing that logic yourself, or two lowercase, or somehow you can use a order one operation to get that logic, right? No, space complexity doesn't matter. One or two variable is fine, right? This is also a local variable, so this is not any very big memory problem. Two variables that is even local is not a big memory problem if you are reducing the time, or if you are not using any inbuilt function, right? So this is fine. Variables like memory starts mattering when you create things like arrays or large strings or something, but two variables is not a memory leak, or there is no problem by creating two variables. Okay, when you will write such a code, right, it would be like so since you have written s.caret so many times, it would be even asked you can take two variables which will store this character. Understood? Okay, fine. Understood. Palindromic string, how did we do this? How did we write this? That is memory leak. That I'll talk about. Chalo, memory we have talked a lot. I'll talk about that as well, not now. Okay. I know I use that term. I'll explain that, but not now, because that I need some time to explain it. If lowercase function is order n, then better to use instead of use it. If it is order n, then it is better to use it. But I am I'm doubtful whether it is order n, right, given the constant. But if it is actually order n, if it has internally somehow implemented it to order n, then better to use lowercase wherever you require, instead of writing that logic yourself, because no matter however you write, you'll get n square, not order n, until you start using string builder, right? String builder will give you order n, but until you get string builder, you won't be getting order. Okay, understood? Okay, so these are the few nitpicking things. Yeah.
Sir, how sir two lowercase function is order n, sir? Because concatenation is used.
So if it is if it has used plain string, then that's what I'm telling. If it has used string, then it is n square, right? It is definitely going to be n square, but when I googled it up, it is showing that it is order n. Now I am also doubtful how it is order n. I'll have to go through that Java docs of how Java is implemented, right? So that's there, how it has implemented, what's the complexity that is there. So I'll look through it. I am very much doubtful that it is order n. It will be order n square, right? So if it has got it order n, then it is definitely using a string builder or something like that internally to do it to lowercase. Okay. So internally it might have used a string builder or an array of character or something like that to get it order n instead of n square. Okay. So this is not possible, right, Mohammed? You are doing a string character assignment. This is not possible, right? So you cannot copy a string in this way, right? So this is so you cannot copy a string in this way. You can directly write a result equals to str. That is direct a copy, right? That is simply creating a copy. You don't need to do a copy like this by running through this, because you cannot do s dot caret I is equals to something. That is not possible, right? Checking to lowercase and changing the constant C1 is constant, right? How is it n square? So this is not n square. This is the order n solution. This is a complete order n solution. This solution is completely order n. There is no string concatenation until you introduce a string concatenation in the loop. This entire logic is order 1, right? And we are running it for order n time. So this logic that we have written is order n. So this is the order n logic. This is not n square. Okay. Okay. Understood, everyone? Any doubts on this? Any more doubts? So this is the order n operation until you do a string concatenation. Now, if you do a reverse of string, that will involve string concatenation, you'll increase the complexity to n square. So that's why this solution, when you're starting by 2 indices, one at the start, one at the end, and you compare them and keep on shrinking it, that is the order n solution, and you cannot better this, right? If you try to find out that reverse string, that will take n square, and you cannot get order n. Okay.
So,
Yes.
so I have a small doubt, sir. So how it's an big of n complexity, because sometimes we use string and sometimes we change the upper character into
We
lower
are
character.
changing the character, right? So we are not changing it in the string. We are not creating a string, right? See, so here we are not changing the string. This is like a character variable updation. So character is like a character variable is like a normal variable. If we update that variable, that is O1 operation. This updation is O1, right?
Yeah.
If we have to update one character in a string, that would be order, right?
Yeah. Okay.
Okay. This done. I guess last question that we have is substring also done. This I explained. So I'll give you time, right? If you ask for time, I also don't. I have not explained sorting, so I don't expect this part to be done, right? Lexicographical order. So so today I explain this. I'll do it this solution. Don't worry, right? If that's hard question, I'll definitely solve it. So, but I'll give you time enough to try it on your own before we solve it. So let's solve this one, right? This one is easy. This one is interesting. I even gave you the concept to this. So see, what is the concept that I told you yesterday? That you can count all the characters in a string, and you can even store it in a very small size array. If you just know it is alphabets, you can take an array of 26 size. If you know that it is going to be alphabets, numbers, special characters, then you can take an array of 256 size and so on, right? This is the size of array you can take, and you can count all the characters. Okay. Now, if you have counted all the characters, then you can use this in somehow, right? If you are asked to print the frequency of each character, that you can do. If you are asked to print the character which has the highest frequency, that you can do. In this question, you are asked to use this array just in a little bit different way. What it has told you that you're given a string S, and you're given an array of strings, which is this. You have to tell whether these array of strings are good string or not. Which of these array of strings? So what is the total number of strings in this which are good? Now, how do we define a good string? So any good string is basically nothing but it should have only characters that is present in this string and no more, no less. Right? So for example, see, here A is present over here, consider this string A, B, D. So A is present over here, A is present over here, B is present over here, B is present over here, D is present over here, but D is not in this string. So this is not a good string, right? A, B, this is a good string because all the characters are present in here as well. Now C, A, C, so here C, A is present, A is present. B is present, B is present, but you have two C, only one C is present over here, and the second C is not present in this. So the count should also be there, right? It's just not like, Acha, count is not okay. Here it is not considered count. Okay. So even if it has, like, if it has multiple times, that is also fine, right? So this is considered as a good string. Okay. So C is present multiple times, C is present from here. So that is a good string. That's fine. So let's do one thing. Let's first simply count the characters in the first string. Is it given that we have only alphabetical string? The string character, it has nowhere talked about alphabets, right? It has nowhere talked about alphabets. So let's just simply take a character set. Yeah.
Sir, if there are only alphabets also, then also I think we have to create a 256 array, right? Because the array is storing the ASCII values, right?
So in that case, there is a
See-
easy
Yes,
solution.
sir, because the indexes are ASCII value, right?
Yes, you can think it ASCII value, but you can do it in this way, right? So let's say you know that all the characters are small characters. So you can store 97 at the index 0, okay, 98 at index 1, and so on, right? So now you will just require 26 character indexes to store it, and that can be 0 from 0 to 26, 25.
Okay, got it.
Okay. So now we don't know anything about it, and it has nowhere mentioned that it is alphabet. So we took it as 256. Now, why 256? Because these are the total number of characters that you can type out from keyboard. Like you cannot create any more characters than this. These are the only number of characters that's present in the ASCII set. Any character beyond it, right? If you try to print what's the if you try to convert 300 into a character, right? You'll get a random kind of character which is not even. So if you try to do this operation, char 300, you'll get a random character which you cannot type from keyword, and this character doesn't exist. We call this character as garbage character because that is not present in ASCII set. Okay. If you try to do this simply, you'll see some random garbage character which is not even valid. Okay. So that's why we can take it as 256. So we can start from 0. We can go to the string length. So that is s dot length. And we can do I++. Now for each character, what we can do is C of s dot char at I. We can simply increase its count. Okay, we increased its count. See what we did. For every character, we just increase its counts in the array. So array is basically having a 256 length, which can have something like this. Think of this array like this. It is an array which can have like 0, 1, 2, and then it will have something like 65, 66, 67, and so on, then 97, 98, and so on. Okay. So now here, what we are doing is 65, 60, and so on. If we get a capital A, so just increasing its count, so initially it is 0, increasing it to 1. Next we get 66, will increase its count 0 to 1. Next we again come to 65, increase its count from 1 to 2. Next we go to 66, we increase its count to 2. If we get A, B will keep on increasing count. Other characters in the array can be 0, right? They will be 0 because we don't get this character. If the inputs is only alphabets, if it is mentioned, then that's why I told you, right? You can take a 26 size array. Here I looked in the question, it has nowhere mentioned that it is 26. So not again using too many space. So this is not memory wastage. See, if we are doing something like this, we are not consuming too much space. So we cannot actually call it wasting memory. We might be having characters like characters up to 128 to 118 ASCII value, right? So that's fine. Okay. See, what is this going to do? This is going to basically do this operation. Let me just show you what it does. Okay, let's just see this. So let's say this is the exact logic that I've written. Okay. So let's take a string S, and let's say it is hello. So what it is going to do, if I just print this after it, it is going to store the count of every character that is present in this string. Cannot find symbol. And can we go with something? Yes, definitely, for sure. Okay. See, so now it is telling now it is telling what's the count of H1, what's the count of E1, what's the count of L2, what's the count of O1, right? So it is basically telling you what is the count of each character in the string. So let's give it a larger string. Let's uncomment this one, which is a larger string. You'll be able to see the difference. So we are getting the count of each characters. And how is it getting this? Because we have just created an array of like very large size, take a 256 size. And what we did over here is we just tried to look whatever character we are getting, right? So let's say we get a H, we'll find out that ASCII value will increase its count by 1. If we get a character O, we'll find out its ASCII value will increase the count by 1. Next, we again get a H, we increase its count. Here we are just looking for those characters whose count is greater than 0, and we are printing it. If you print all the characters instead of checking this, we'll get a lot of characters whose count is 0. We'll get a lot of characters whose count is okay. Let me run this. See, so you get a lot of characters whose count is 0. You get a lot of characters whose count is greater than 0. For example, here space is 13 times. If you go to numbers, you see this 2 is 2 times, 3 is 1 times. If you go to alphabets, you see W is present 1 times and so on, right? So you get the count of each character. E is present 6 times and so on. Hashing less space complexity. Obviously, this such the hashing, right? This has a lesser space complexity, lesser computation. ठीक है? Understood this concept? Basically, array को use कर लिया character count करने के लिए, and we use the concept of ASCII. ASCII का concept पता था हमें कि ASCII basically हर एक character को number बना सकता है, number बन सकता है तो index भी बन सकता है array का. ठीक है, उसको array का index बनाया और उसके वो जो index बन रहा है उसी पे उसका count store कर लिया. अब वो भले 10 बार प्रेजेंट हो, हमने तो उसके एक ही इंडेक्स पे उसके काउंट को इंक्रीज करा है, तो फाइनली h मान लो 10 बार प्रेजेंट है, तो हमने एक h का जो भी इंडेक्स बन रहा है उस पे काउंट को 10 टाइम्स इंक्रीज कर दिया. ओके ठीक है. कंटेन्स फंक्शन कंटेन्स तो बहुत इजी है. कंटेन्स इजी. चलो आई विल डू अ फ्यू स्ट्रिंग फंक्शन. डिफिकल्ट वंस वी हैव डन, इजी वंस आर रिमेनिंग आई गेस. ठीक है. So now here what you have to do, here basically for every particular string in the array, we figured out this hash, right? We figured out this like count of each character. Now what we have to do is we have to we can go for every string in this array. Okay. So what are the string in this array? First string in this array, let's say is as that's a of I. What's the first string in this array? A of I. So for a of I, every a of I that is the string, we have to iterate through each character. Now, if each of these characters is less than a of I, that is the string dot length. Okay, this is the array of string. See, this is the array of string. This is not an array. This is the array of string. Seeing the difference? Array of strings. Every array cell is containing a string. Okay. Now, this thing is we are going through each string, each character in the string. Let's say a of I string, right? We pick one string, which is a of I, first string, AB. We have to go through each character in this and check whether it is present in the already existing string. So that we are given, right? S. So if this character a of J, okay. So what's the character? Chalo, what's the character that we'll get? So let's find out this character. Character C, what's the character? A of I is the string.
It's a very good question. The ball I want to show tomorrow. I want to come.
Sorry, someone is on mute. Yeah. Okay, see. So A of I is the string. In the A of I, we want to get the character at index J, right? Now this character should also be present in the string S. Now, can anyone tell how will we check whether it is present in the string S? I wrote the entire logic, just one if condition. How will we check? So this is A of I string. In this A of I have written a loop, right? Now, greater than 0, what should be greater than 0? Okay, so this is also named as C, right? Let me name it something else. Count. Okay, let's name it count. Right, now tell me. So this array count of C, right? Count of C in the previous string should be greater than 0. If it is greater than 0, then we are fine. If it is less than 0, then this is not, this is a problem. This string is not the string we are looking for. So we can mark the flag as 0. We can mark it false over here. 1, and we can take. You can take it boolean or take it initially true and then mark it false. That's also fine. Whatever you want to do. If finally the flag is 0, that means this condition was never hit. The count of every character was greater than 0. So we can print the string. How much you did not get any part of it? Tell me honestly, I'll explain it. I know this is tricky. This is one such interview question that you will be asked. It's a direct like kind of interview question which you'll get.
Sir, actually, we want to get the count, sir, not the string.
Oh, we don't want to get this. We want to count it. Okay, so we can do a COUNT count plus plus. Okay, we have family count. What it? Comparison part is little bit confusing. Okay, chalo, I'll break it down. We got the count as 2. Why do we get it as 4? found plus plus. The flag is 0. Acha, it will. I've checked for less than 0. It should be equal to 0.
Sir, can you explain the line number 17 one more?
Yes, yes. I'll explain this entire part. Don't worry. Okay. So first of all, tell me, did you all understand the first part where we are counting and storing this into an array? Easiest thing we did was कि instead of if let's say we don't have this array, ठीक है, ये array नहीं है, ठीक है, let's say you don't have this array. What you need to do is whenever you want to check whether a character is present, let's say you want to check whether character C is present in the string S. What you will do? If you don't have that array, what you will do? Simple logic, right? You have to check basically each character is present in the above string or not. You don't write this logic, what you will be doing? You will be going through a loop. You will be writing something like this, right? For loop. And I is equals to, let's say k is equals to 0. K is less than equals less than, let's say, s dot length, which is the string. And then you can do k plus plus. If this character is equal, if s of I is equals to s of k, sorry, s, if s dot caret k is equals to c, then you say, okay, we found it. Okay, you can check, okay, found. We'll say found. And you will basically do this, right? Found is equals to 1, we found it, and done. Break. We found it. If not found, if found it, then fine. If you did not find this character, then you can say flag is equals to 1 or something. Right? We'll do this. For a loop likhna padega to check whether this character is present in the string or not. Now, how can we do this in O1 time? Can we do it in O1 time? Right? Understood this? If when you get a character from this string, what we do is when you get a character from the string A, you want to know whether it is present in the string or not. Wahi to karna hai, right? For every string in this array, you have to check whether each character is present in this or not. Now, what you have to do is if you get A, you will go to the string, each character by character will check whether it is present in it or not. You'll check, you got B, you check in this entire string whether it is present or not. You get D, you check in the entire string whether it is present or not. Right? Now, instead of doing this, right, which we don't like, right, this is a very heavy logic. We have run like order n, and this is again order n. Very on cube solution doesn't look good, not even optimal. Yeah.
So actually, this is the explanation of contains function, right?
Yes, this is the explanation of contains function. Yes. So this is the entire logic of contains function. You can use a contains function to check, but that is again order n. Okay, so since this is like I've written, so let me cover that contains function that's there. So there is a function that will also check whether a particular character is present in a string or not. So you like how would this work? So let's say you have a string s is equals to hello. Okay. So how do you check whether this is present, any character is present in this or not? You can simply use this contains function and whatever character you want to check, s dot contains, and you pass this character, let's say A. I guess it doesn't work on character, so you need to pass it as string, and it works for so it is s is already defined now. That's a bigger problem. So there is error. If we run this, see, now it is telling it is not like you cannot pass character. So either you do it in this way, A, which is fine, or you do it in this way. If you have this as character, or you do a plus A, right? Okay. So now this would convert it into string. Now it is telling false. A is not present, right? A is not present. It is telling false. If you write H, so it will say H is present because it is present, right? Now, can we write this logic ourselves? Very simple logic. What we are doing actually? We are going from 0 to s dot len I plus plus. Let's say this is a very simple function, right? So what we are doing over here is, what's the definition of this function? If s dot caret I, this is double equals to, let's say whatever character you are looking for, right? Whatever character you are looking, A. Then you return true from this function. Otherwise, if you don't get this, at the end you return false. That we did not find this. Okay. This is how the contains function will look like. Yes, understood this part. So what we are doing is we are basically checking whether that character is present. If it is present, we return true. If it is not present, we return false. Right. Now this is what the contain function is doing, and we can do it, but this is again order n operation. This is an order n operation to check, and this is exactly what we wrote over here. Right. This is the exact logic that we implemented. Or if you use the contain function, that would also do the same thing, but in order n. Right. So both the logic, either we write or we use the contain function, that is going to give us order n. Now how can we get it in order 1? If we can simply compare something and check whether it is present or not. How will we compare it? If we already know if this is present or not. Now this is a very easy technique or very easy trick of using arrays over here. If you want to know whether a particular character is present in a string or not, you can use arrays for that. How can you use arrays? So you can basically count the occurrence of each character in the string and store it in an array. How can we store a string character into array? So string character nothing but ASCII value, right? So you can create an array like this, and each index in the array stores the count of each character in string. Okay. So each index in array stores the count of each character in the string. Okay. So if that character is not present, you get the count as 0. If that character is present, you get the count as 2, 3, 5, or how many times that character is present. Okay. अच्छा ये समझ नहीं आया? ठीक है. Check over here. So what we are doing over here is, see, हमने यहाँ पे क्या करा है? We are basically having, let's say, this is our ABC. Okay. This is our characters. So we did count of A, caret I, caret 0 is A, count of A plus plus. So what does this mean? So count of A क्या है? A का मतलब क्या है? This is basically not a character. This will change it to its ASCII value implicit conversion, right? Count of 97 is equals to count of 97 plus 1. So what is count of 97 currently? It is 0 plus 1, which is 1. Understood? Count of 97, we change it to 1. Without line number 9, we won't be able to get the same complexity if we don't use this logic. No matter however you do it or use the inbuilt function, you'll be checking that in order n. But if you use this, you can perform that check in O1. Okay, whether a particular character is present in string or not. If you just try to have this array, you can perform this check in O1. Otherwise, no matter how, if you try to write that logic yourself or you implement a condense function, you will get this logic in order n, not in O1. But here now we can check in O1 whether a character is present in the string or not. Now, if the count of that character is 0, which we want to look, that means that it was not present in the initial string. Otherwise, we would have increased its counts. If it is present in the string, then its count will be greater than 0, not equal to 0. So we will not do anything, right? If it is equal to 0, that means this character is not present. We mark the flag as 1, we break. If there is even one such character in the string that is not present, so for example, here, there is one character in the string D, which is not present in the initial string. So this is not a good string. So the flag is 0, we don't increase the count. Sorry, flag is 1, we don't increase the count. If the flag is 0, we increase the count. Now understood? कि क्या करा हमने?
सर एक बार ड्राई रन करके समझो.
ठीक है, चलो ड्राई रन करते हैं. See, so the first thing we created a count array. Count array क्या कर रहा है? Count is just a simple array. ठीक है, 256 length का है. ठीक है. Let's check for this example. So where you have ABC. So what we are doing over here is, so first iteration, we go to here I equals to 0. We are doing count of A plus plus or count of 97 plus plus. So count of 97 increases its value to 1. Okay. Next iteration is B. So we do count of 98. So this is B. So count of 98 plus plus 98 increases its value to 1. Okay. And then finally 99, count of 99 increases its value to 1. Rest all the other values in the array are 0. Because we never increase their value and all of the other values is 0. Okay. So what's the complexity of doing this thing? This is order n. Okay. This is the order n operation. This is order n into that firstly is the n, and then this is running for the length of each string. So whatever is the highest length of string in A, that will be n. A strings highest, this is 1000. This is also 1000. So we are 10 to n square, which is 10 to the power 6, which is fine, right? 10 to the power 6 is fine. But if you do that contains, then it will become 10 to the power 9, which is not fine, right? So contains should not be used because of these constants. It will make it 10 to the power 9, and you should not be using it. Okay. Okay, I'll explain the index of and last index of. That's, I guess, only 2-3 functions are remaining, right? Index of, last index of is 1. Uppercase, lowercase, I explained. Okay, chalo, I'll explain that as well. Okay, now we got this count. So what we are doing over here, check. So we are starting with the first character. Let's start from here. So we are having AB. So firstly we check, okay, AB. This is A of I is AB. This is the string. We are running for each character in this. J loop is running for each character. We get A. The first character C is equals to A. We check whether the count of A is equals to 0. So count of basically 97. Is it equals to 0? No, this is not equals to 0. It is 1. So this is false. We don't do anything. Next again, count of B. Character changes to B. Next iteration, we check count of B, is it equals to 0 or count of 98? Is it equals to 0? No, it is also 1. So we don't do anything. Flag is 0. So when we come outside, flag is 0, we increase the count. Okay. Next iteration, when you have this string as ABD, for A and B, it is not going to satisfy. But when you change it to D, count of D character, and you compare it with 0, this is a count of 100. Which is actually 0. Count of 100 is 0. Count of 97, 98, 99 is 1, but count of 100 is 0. So this will be true. We change the flag to 1 and we break. Outside the loop, we check is flag 0. No, we don't increase the count because this is not a good string. Okay. हाँ वो भी कर सकते हैं. So that is fine, right? So instead of doing this in a single line, you can do it in 2 steps as well. So for example, if this is complicated to understand, you can do it in this way. So which index we want to increase? So int ind is equals to s dot char at I, and we do s dot is ct of ind plus plus. Done. So ABDC is fine, right? We'll be breaking by marking flag as 1. We don't even need to see CC because if D is present, it is not a good string, right? If D is a character. If it is ABDC, we don't need to count that string, right? Because D is one character which is not a valid, which is not present, right, in the initial set. So we should not be counting that, and that's what we'll be doing, right? We'll break it. We don't need to count even if. So if the first character is F and that is not present over here, so we don't need to count anything else, right? This is not a good substring because F is not present initially. Okay, understood this? Right. This looks good then comparing everything. Yes. CABC, so this is present because C is present over here, right? Even if the number is not matching, but that character is present, right? It is, so it has only told that the character should be present. It has never told that if the count of characters should be also equal, right? If I increase a layer of difficulty in this, that the second character will be called good string if the count of that character is exactly equal to the count of the character in the first string. So can you check that now? क्या वो check कर सकते हैं? Second, you need to then count the count of each character, and that would again be, that would be n square itself. That would be n square itself. Okay. So think of that question. I'll not solve it for you all now. Right. Yes, that's a good solution. You can check decrement count, but there is a problem. You'll need to, since you have a lot of strings to check, if you start decrementing the count, your count will become 0 for first string itself if it matches, and the other strings, how will you check them? So A, B, C, D, E, F, or F is extra. So here in our situation, see, we traverse that string completely. We'll traverse A, B, C, A, B, of that will be fine. But when we'll get E, so we'll check is character E present in the string? No, that's its count is 0. We simply mark flag as 1 and break. Right. So since if flag is 1, we don't count that string. So we'll not be counting that, which is fine, right? We don't need to count that string. Okay. Understood? Okay. Do we need this logic? Need the solution? Or will you try it? Well, I'm pasting the solution anyways. You can try it once. This is good strings. Paste it over here. I have few string functions to discuss, and then we can go to sorting. If there is more doubts on strings, I guess we can discuss it, take one extra class to discuss this questions, but these are only the concepts, right? See, if there is string functions, builder and buffer, there is a separate class for that. We have it after sorting. I don't know why it is after sorting, but it is after sorting. Okay, so you'll have to bear with me till then. Okay, so we'll start with sorting. We'll okay, you have doubts in few string functions. I'll explain what is index of, what is last index of, what is contains. Contains I did, right? Contains we did. Replace or replace all these functions I'll explain. Okay, chalo. Quickly go back, come from the dinner, right? Go to your dinner, come back quickly. We'll start. Okay, take your break. I'll explain sorting and then string function. So right now we'll discuss 3, and then when you will learn about recursion and like concepts, you will learn about merge sort, heap sort, quick sort. So you'll learn 6 in total. Or is there anything else that you'll learn? Counting sorts. So you'll learn 7 in total. Okay, in the course, and even more than that, but at least 7 is there for sure. Okay, quickly have your dinner, come back, we'll continue the discussion. Okay. Hello everyone. Welcome back. I hope you all had your dinner. Okay. So how many of you cooked Maggies? No one. Achha, is the mess open this time? Mess doesn't close. Is this time? Does this 10 o'clock timing suits all of you? Those who are in college hostels, you get ample time to have your dinner at least, right? No one is waiting hungry. Chalo. I think we can continue then. What did you eat? I thought for 15 minutes what to eat. I had just fries, and yeah, then after the class I'll again think what to eat, and then I'll sleep. Okay, so let's continue. Maggie, chalo, great. Okay, so this is what string said. Let's see a few more functions on string, right? So let's see a few more functions that you're talking about. So we saw contains, right? So see, basically every string function is nothing but a simple logic that you need to write by traversing a string, right? So for example, let's say there is a function known as index of. What does this give you? If you pass any character, this will give you the index of the first occurrence of that character, right? So how can we get that index of first occurrence of a character? So for that, let's say we have a string s is equals to hello. Let's just check this function. So what we do over here, we can simply do s dot index of, and we pass that character, let's say a. Okay. So this character is not present, so it will tell us that this character is not present. It will give us -1. Okay, see, this character is not present, but if I give it a character that is present, let's say e, it is going to tell me that this character is present at the index 1. Okay, now if we have multiple e's, which index is it going to give? It is going to give us the index of first occurrence of this. Okay. Okay, so now can we write this ourselves? Yes, we can. We can do 0 to less than n I plus plus. Now you can check if s dot char at I, if this is equal to the character that we are looking for. Let's say e is the character we are looking for. So what we can do is we can take the index, right? So this is our result. Ind is equal to, let's say, -1. If this is equal, then we update our index to I, and then we break directly. Once we got that character, we break it, and finally we print system.out.println Ind. Okay, now this is fine. This would check if that character is present or not. If it is, oh, maybe check it for length s dot length. So order in, yes, order in. Index of is again an order in operation. This is order in, no concatenation, nothing required, just a simple comparison, but we need to traverse the string. So this is the order in operation. Now, can you so this gives us the first index. There is similar to this, there is a function which gives the last index, right? It is known as last index of. It is in this last index of. Okay. Now, what does this function do? This function tells you the last index of E. See, this is telling that last index of E is 5. Now, can you tell me what do we need to change in this function? So this also tells us the last index, not the first.
The break, sir.
Bus. Just remove the break, or you can start traversing from the reverse of the string. Either you reverse the loop or just remove the break. Both of them is going to work, right? So complexity wise, it is both of them are order n. It doesn't change anything, but you can use like reverse loop and use break. That is also fine. Okay. Understood. So how we can get, so index of, last index of, yes, clear. Okay. Okay. This is fine then. Why? So this is giving the last index now. When we removed break, this is giving the last index. See, what is happening is when it will match for H, it is not matching. E, it's matching. So it's telling index is 1. Then see O, this doesn't match. So it tells, okay, these all characters doesn't match. And then it sees E again, which is matching. So it updates this index from whatever it was pointing to this current index, which is the last index of E. Okay. Okay. So this is index of last index of. Okay. What else? So index of, last index of, we did. What else? So there is a contains function we did. There is okay. Then there is 2 lowercase, 2 uppercase. Time wise, I feel it is n square. We'll have to check. Okay, I guess the initial result that you're seeing on Google is little bit like wrong, I guess so. But so this would basically convert any string into lowercase. Now, if you have this any uppercase alphabet, so that would get converted to lowercase. How can you do this yourself? Can you do this yourself? Can you implement the logic yourself? We did it, right? You just try to pick that character, convert it into lowercase, and then add it to the new string, right? Add it to the output string. That's fine. You can use 2 uppercase to convert it into uppercase. If any character is in lowercase, you just check that and you convert that character to uppercase, right? Hello. Okay. So you can write this as well. I already told you about equals to equals that will check for strings. There is again another function similar to equals, which is known as equals ignore case. Okay, so what does s dot equals compare? Whether the first string is equals to the second string or not, right? So if you do it equals, it will tell whether the first string is equal to the second string or not. S is equals to, let's say, hello, and the second string is string 2 is equals to hello. So this would tell you whether the 2 strings are equal in form of the value. Okay, so it is equal. But if you add a new character, it would say you that this is not equal. It will tell you false. Okay. Now, if I change this, so now even though this is like equal, it will tell not equal because this is case sensitive language, right? So capital H and small h are not equal. But there is a function which is like equals ignore case. It will actually compare 2 strings by ignoring the case, right? So you can use equals ignore case. Okay, so now this gives you true. So there are 2 functions. One is equals, which just compares whether it is equal or not, and then there is equals ignore case. Okay. Now, can you implement both these functions yourself? Is it difficult? You just need to traverse both the strings. If the lengths are not equal, then the strings are not equal right away, right? If the lengths are equal, you just need to do the traversal. You need to check for each character. If both of them are uppercase or if both of them are lowercase, then you directly compare characters. If any one of them is upper lowercase, you just convert it to that case and you can compare the character, right? In case of equal ignore case, in case of like equals, you don't even need to convert any character to upper lower. You directly compare the characters. If they are equal, they are equal. If they are not, even though they are same characters, if they're in upper and lower case, they are not equal, right? As per equals. Okay, understood? Okay. Okay, no doubts. Okay, so try to write these implementations yourself, right? Even if you equals ignore case, so basically this would ignore the casing. So for example, here see, this is a small h and small e, but in this it is capital H, capital E. But this is giving us the result true. Why? Because it is not considering the case. Basically, when the comparison is happening, it is converting, let's say, either to lowercase, right? So both the character will get converted to lowercase and it will compare it. So this is already in lowercase. We won't convert this, but this is uppercase. We'll convert it to lower and then we'll compare it. So small h is equal. Right? So we did that earlier, right? How we can convert both the characters into lowercase and we can compare, right? Okay, understood? Now one interesting function is parse India. So that so see in the coding exams, I'd say ki in the online rounds you can use these functions that saves your time. Okay, but for example, at times, for example, substring function, we saw that in case of print all the substring. There it was increasing the complexity to n to the power 4, but without using that, we could have got n to the power 3. Right. So if the function is increasing your complexity, right, similar to the previous question as well. So in the previous question we saw it is like checking that in using contains function is order n, but if we use that map, it is order 1, right? So at times you won't even have a choice to use the inbuilt function. You will have to write that logic yourself, right? Okay. But at times you can use it. For example, you have 2 strings, you have to compare them. So you can use equals ignore case. whatever is your requirement, right? If the interviewers explicitly ask you ki write a logic or equals ignore case, so how will be this equal ignore case be? So let me write this. Okay, so let's write this logic. How will this function look like? So let's say we'll find the length of both of them. Int n is equals to s dot length, and int m is equals to s2 dot length. Okay, both the lengths we found out. Now we'll check if n is not equals to m. If this is not equal, then we can right away say return false. They are not equal. Okay. If it is equal, else if it is equal, then what we need to do is we need to run a loop. If the lengths are equal, then we will run a loop for n. We'll check if the characters are equal or not. But before checking for the character, we need to ensure both the characters are lowercase characters. So let's say we'll write this simple logic that we earlier wrote at s dot cat at I we'll convert both of them to lowercase before comparing. So we'll convert if c1 is greater than equals to a and c1 is equals to z.
C2S2 होगा सर.
अच्छा c2h2 होगा. Okay. Okay, thank you. Okay, now c1 we can just do c1 plus 32, and same goes, just we'll copy this entire logic and we'll do it for c2 as well. This will change to c2, this will change to c2, and this will change to c2, this will change to c2. Then finally we'll just compare. If c1 is not equals to c2, we'll return false. Let's return false, and at the end, if this is equal, if all of them are equal, finally return true. Understood? Simple logic. So basically we did, if the lengths are not equal, we right away return false. We don't even need to check the strings. There cannot be two strings of unequal lengths that are equal, right? Right. So no matter what, if we are just comparing it character by character, so find out two characters, and so equals is case sensitive, equals compare it in using the case sensitive. So this is equals ignore case. This logic is for equals ignore case. Equals is just this, right? In equals, this is the function. You don't have this. Okay, so this is the equals wala function. In the equals ignore case, we are just adding this logic to ignore the casing. So we are just converting everything into lowercase and comparing it. If they are lowercase, so this condition will not satisfy, right? So if c1 is a lowercase character, this condition will not satisfy. We won't do anything. We'll not alter it in any way. But if it is just in the uppercase range, if it's just a capital alphabet, right, then we'll alter it. If it is a number, if it is a special character, or if it is a small case character, we are not going to alter it. We're just doing this for the capital case character. Understood? Clear? Okay. Okay, so this is it. So now there is an interesting function. I guess you can see through these functions, very easy to implement. Okay, always tell you I implemented so many functions, you would have got the idea by now. Okay, thoda so idea laga hoga. Okay, so I'll do this. See, this is a good exercise that I always tell students to do. So do this, right? Go to here. Okay, these are all the inbuilt string functions. You don't need to do all of them. I like pointed out the ones you need. So this is one you will be using caret. So there is a table. Is it there a table? No, there is not a table. Okay. So this is that like, so you don't need code point at code point before code point count. You don't need this. You need caret. You need compare to ignore case. You don't need it. Okay. This is also same, right? So we need compare to. I'll explain about this. This I'll explain in detail. Don't worry. Concat contains ends with equals ignore case, index of is empty, last index of length, right? So replace first all, replace all, replace first, starts with splits the string into array of substrings. Okay, now what is this array of substring? So let's check what the splits do. I have not used the splits. Someone asked in chat as well. चलो क्या करता है So concat क्या करता है बताओ? What does concat, do you think what does concat would be doing? joins to string, right? It is the same concatenation operation. Right, append both the strings together, one at the end of them. Split. How does split work? So split is not even having a page.
सर रेंज ही देना पड़ेगा लगता है.
Splits the strings into array of substring. There is no definition as well. I've never used this function. Like, I don't think this is very useful. If it was, then I would have ever used it, felt ever need of it. So if it is storing the strings into a character, right? So that you can anyways do, right? You can create a character array, put it. If it is, let's say, we need to pass it the delimiter of split space. Empty character we can't pass. We need to pass it as a space. Empty character literal. Okay, we need a delimiter to pass this. Char cannot be converted to string. So it needs a space as string. Acha, got it. So this is basically creating a character array by splitting this into by using space. Oh, you don't need this. You don't need. If you are ever going to use this function, interviewer is right away going to tell you to basically write this logic. Okay. So no interviewer is going to accept this. So I'll tell you what this is doing. So this returns a string array. Okay. So let's call it as A. So what this is doing, so basically if you have a string, it is going to give you all the words in the string. Okay. So for example, let's say I go to 0 less than n, I plus plus, no, not n, this is a dot length. Now if I run this, see what it, oh. We have extra one. Okay, so now it is telling hello, but if I give it multiple world, hello world, I am Ritik. Let's run this. It is going to break this into multiple strings. See, so each string is broken by the like the delimiter that you pass over here. So this we call as delimiter. So there is a similar function in JavaScript which splits the string. So I remember it now. So if you do this instead of this, if I pass it, let's say character like, let's say is there any character that occurs multiple times? O. There is a character O. Am I seeing O 2 times? Yes, O 2 times. So let's split it by O. So you'll see the first string is from here to here. Okay, and the second string is from here to here. See, so the first string is till W. Then the second string is starting from here. It is splitting the string by O. Okay. So before this O, this is the first string. Second string is just a space and W, and third string is after this O. So you can just pass it any delimiter, and it would break it using that character. So ideally, if you would need it to pass this space, and it will just split it into words. Okay. Can we do this? Can you all do this? So get an array of words out of string. Yes, very easy. You just need to traverse the string, create string, put it into an array, right? So you already know how to count the words in a string, right? You already know how to count the words. So that makes your life even easier. Very easy. See? So now similar, all the string functions you can easily implement. There is no string function that you will face difficulty to implement. Okay? All the string functions are super easy to implement. You just need to traverse them and you need to do it, right? So that's why I'm telling from starting, you just need two string functions that you cannot implement. One is caret. You cannot implement this, and you will not be able to implement the length function. Okay. So these are the two functions you need. Apart from this, all the other functions you can implement. Most of the logics are also very simple and very straightforward. So you don't even need to know any anything about strings. That's a plain simple the kind of logic that you will write on any array, right? If I give you the same question on array, if you could do this operation on array, that's the same thing, like contains or replace, or let's say find, or let's say equals or equals ignore case, something like that. So do you use, so that's right. So that's what I was telling. At times you might I'll say first approach should be thinking about functions. if you know that, if you remember it, you can use it. So for example, split was one function. I never used it. I never knew it existed in Java. Okay. So I never felt the use of it. If I ever like felt the use, I would have done it myself. Okay. So ideally you should try writing them yourself, because most of the time interviewers don't like buy this solution. They ask you to write the split function. If you write this, it will tell you to like write the logic yourself, right? So it will tell you to write that logic. So in interviews, it doesn't work, right? All these fancy functions don't work in the interviews. You'll anyways need to write them. In case of like when you're doing the online test, or you're giving the like online rounds for the companies, so there you can use them if it is saving your time, but at times you will get a worse complexity than you would get by writing that logic yourself. So for example, we saw it in the case of substring, where it was increasing it to n to the power 4. We had a contains function, but that was order n, so it was not solving our problem. So we had to use that our form of like storing the count in array, so all those things, right? So at times it works, at times it doesn't. So yeah. So if it is solving within the time constraints, you can use it in the online round, but you need to know how this can be implemented. If the interviewer asks you, can you do it? You need to say, yes, I can. Okay. Can we implement the split by checking caret? Yes. So you can check the caret each. If it is equal to space, then you can split it. If it is not equal to space, you don't need to split it. Okay. So that's all. Okay. So now we have done few string question. I told you about functions as well. You have this list. You can try to implement these functions yourselves. I gave you idea about how these are implemented. Now try to write the logic of all these string functions. Don't write this get bytes, get chars. These are not useful format. Okay, so copy value of all these things might not be very much useful. Try to write the ones that you like. So for example, let me write those strings functions. So you need caret. So let me write all of them at a single place. You need caret. You need index of. You need last index of. So these all I'm talking about, you have to implement, right? Equals ignore case. Contains you'll never be using, because if you ever feel the need of contains, then you will be, if you want to do it multiple times, you will need to create that logic of storing it in an array and then comparing it. Okay. What else did I leave? Starts with, ends with. Length you can't implement. Length is like the basic one. You can't implement, but you need to remember this. That's got node index of. Is empty. Is empty is not required, but you can check. You can check it using length. So is empty is basically checking the length. What is empty doing? Is empty is simply checking whether the length is equal to 0. If the length is equal to 0, then there is no character. Last index of. We have done replace. Replace you need to write. I told you the logic for replace. Remember the logic for replace yesterday I gave you how you can use replace a character in a string, replace all the characters by using string concatenation. You can do it. Very worse complexity, but works, right? Replace all. Split I just showed you, right, what you can do. Substring I showed. Substring is one thing. Substring avoid using substring because it is n square. And most of the times, if you ever need substring, if you do it within the question itself, you'll get an order n. So the substring is something which you should generally avoid a lot. Two lowercase, two uppercase. I suspect their complexity is n square, but Google is telling us it is order n. So I'll need to validate on the Java docs whether it is order n or order n square. If it is order n, then that's an interesting question of how they have done it. Trim is something which you can do yourself. So trim is basically removing the number of spaces from the start and number of spaces from the end. Do you enjoy React more or backend more? I enjoy both, right? I'll say. So yeah, if the project is interesting, that's what I enjoy, right? It requires actual engineering. You need to do some things, right? So that's interesting. There is one function that I skipped, and I know few of you noticed as well. That was compared to that. So I'm going to cover now. I'm going to take 15 minutes to explain this function because this is very important when we talk about string. This is how your you are going to apply sorting on string. Okay, so there is a function one is compare to, and there is a version compare to ignores case. This function is that important. Okay, so I'll explain one of them. Other one is you can easily understand, right? You'll get the idea of what it is going to be. See. Okay, so what is okay, so if I give you two strings, so till now we always thought about comparing them in terms of equal or not equal, right? For us, these two strings were either equal or they are not equal. We never talked about strings being greater than or less than, right? We never talked about this, like whether the first string is greater or whether the second string is greater, because this did not make any sense, right? We only talked about whether they are equal or not. या तो string equal होगा, either it is equal or it is not equal. But we never thought कि can there be any way whether it is greater than or less than, right? We know that greater than, less than symbols are just for characters, and if you just try to apply them, right? If you just try to check S1 is greater than S2, this is not going to work, right? If you just say system.out.println, let's say yes. If I run this, it's not going to work, right? See, bad operand types. Greater than comparison doesn't work. But are actually strings greater than, less than? Is this actually a concept, or is it just something which cannot be done? So actually there is a concept where we need to check them greater than, less than. What is this concept? You know this from childhood, right? You have used it. Trust me, you all know this. That is lexicographical order of strings. Okay. Now, so you'll say, okay, sir, we are hearing the term for the first time, and you're telling me know this concept. You actually know what the lexicographical order of string is.
Mainly it's a dictionary order.
Yes, it is the dictionary order. It is nothing but the dictionary order of string. Now, you even know how to sort this. You even know which string is greater, which string is smaller. So if I give you these two strings ABC and I just ask you to compare it with ABD, which string is going to come first in the lexicographical order, which is going to come second?
ABC first.
ABC first. Everyone knows, right? How did we get this ABC first? Because we are used to comparing it. We compared the first character, it is equal. We compared the second character, it is equal. And then we compared the third character. Since the third character was not equal, then we thought, okay, this is going to come first and this is going to come second. If I give you a string like this, let's say X and BC. So these two characters are equal. What you would do is you'll just compare the first character. You'll say, oh, first character is not equal. So we'll just say, okay, this string is smaller and this string is greater. Now, whichever is in the later part of the ASCII set, whichever is the later part of the alphabetical order, that will be in the later second string, and this will be the first string. Okay. So what we do is we are firstly looking for the first non-matching character, and we are comparing. It is similar to that array subtraction question where we actually try to find if the array lengths are equal. We try to find the first non-matching character. Here, even if the array lengths are equal, not equal, doesn't matter. Here we just compare the first non-matching character. If we get that first non-matching character, then we say, okay, this is not equal, and this is smaller, this is greater. Okay. Okay. Now let's check whether it is greater. So how does this work? So we can use a compare to function. So there is an inbuilt function compare to, which checks whether this is in the order or not. So the return value is actually tricky over here. So again, you don't get a true false value, but if you actually run it, you'll get an integer value, whether it is 0, 1. Okay, so int cannot be converted. Okay. Actually, sorry, why we are doing this? Let me copy this here. Let me just try to do it. So you actually don't get an integer value like you were getting for equals, which was just telling whether it is equal or not. Here you won't get that. You'll get a numeric value like 0, +1, -1, +2, -2, -5, something like that. So let's say if I just do it as, let's say, A over here, okay, you will get actually positive value in this situation, okay, which is 11. Now, if I just change to, let's say, this is B, okay, you start getting a negative value. Okay. Now, are these values random, or is there any logic between this?
Difference between ASCII code?
Yes. So it is the difference between the ASCII values of two of them. So it is basically a difference between the first non-matching character in S1 and S2 and its ASCII value. So let's say we will find out the first non-matching character, that is fine. So we'll find out the first non-matching character. There can be all the other characters can be non-matching, doesn't matter. So this is the first non-matching character, B and E, right? So what we are getting, so what's the ASCII value of B? It is 98. What's the ASCII value of E? It's 101, right? It's 101, 101, right? So 100, so it is 98 minus 101. So the ASCII value of B is 98. The ASCII value of E is 101. So when you subtract 98 minus 101, you get -3, and that's the result that you're seeing over here, -3. Okay. Now if I change this to E and this to B, what will we see? Will we see +1? Sorry, +3. Yes, because this time you'll get this as 101 and this you'll get as 98. So you'll see +3. Okay. Now this we can use to sort, basically this is enough information to sort an array of strings. Okay, this might look like, okay, for one string this is too much info, but when you want to sort an array of string, this is very useful. You exactly can predict what is the order of the strings using this difference value. So if the difference is higher, that they would be in that much extreme. If the difference is lower, they will be that much close. Okay. So let's try this. I'll explain about sorting and then I'll come to this, but let's try to implement. Can we implement this function ourselves? Looks like implementable. Easy, not easy. So let's do a few checks. Okay. Let's do one thing. There are a lot of edge cases over here actually. Okay. Let's say the first string has character and second string is an empty string. So what does this return? So there is no non-matching character that you'll find out the difference. So what it is returning? It is returning 5. Now from where it is getting 5? What is this 5?
Sir, what if the first string is like hello and the second string is hello ABC? Then what will be the output?
Hello?
ABC, like something else.
So even if it is okay. So if it is non-equal, so that's what I was doing. So see, now if this character is non-matching, so the first non-matching character is this A. So this would come later, right? This is an empty character. There is no character from here to subtract. This is an empty character. It is giving -3. Okay, we are comparing S1 with S2. Yes. Okay, let's check. Think of why this is giving -3. That time it was giving 5. So this is. Yes, this is remaining length. Yes, thanks for pointing that out. Yes, that is the length. So in this case, it is giving us the length of this remaining string that is present over here, right? If I change it to D, this is going to be 5. Yes, I remember I say kuch tha edge case. So see, now it is giving -5. But if you have this thing in the first string, it is going to give you +5. Okay. So if there is a lot of cases to involve. So if you might get this as a complete interview question to implement this compare to function. Interviewer might even allow you to check what this edge cases behavior is like for compare to, but you have to write the logic yourself. Okay. So see what we need to do. So firstly, let's take two index. One is I equals to 0 and j is equals to 0. Okay. Is it a 45 minutes? Might not be 45 minutes, actually 15 minutes, I would say. Interviewer might be expecting this one to be done within 15 minutes. You might not go to 45 minutes. Okay. Okay. So he wants to see just whether you are able to handle these edge cases. He knows that you will just find out differences. I know, right? I know it's too many edge cases. Okay. So see, what we'll do is so let's check, right? Let's see what we can do. So int n is equals to s dot length, and m is equals to s. So this is s1, and this is s2 dot length. Okay. So we will see this should be less than n and j should be less than m. Okay. So if this s dot s1 dot caret I is not equals to s2 dot caret j. If this is not equal, then we found the difference here only, right? If it is not equal, then we are done. So let's say we will have this difference, which is initially, let's store it as -1, initially -1. So let's change it. So we'll find out the difference is s1 dot caret I minus s2 dot caret 0. So positive, negative, whatever we are getting, we'll store this, right? If the first character is greater, then we'll get positive. If the second character is greater, then we'll get negative. Okay, we get the difference, we can simply break. Else, if this is not true, this is equal, then we can simply do I plus plus j plus plus. Okay. Finally, if one of them exhausts, right? If finally one of the string exhausts and the other string has characters, right? So if let's say if the difference is still equals to -1, that means we ended up this loop because we ended this loop not by hitting break. We ended this loop because either I became equals to n or j becomes equals to n, right? In that case, right? So if let's say I is equals to n, in this case, what we have to do is, in this case, we have to put the differences. We have to update the difference, what it is going to be. I has become equals to n and the j has still characters. Okay, let's say if I and j, both of them has equals to this, then the difference is going to be 0. Okay, else if both of them are not n, only the first string has become equals to the like the length, and the second string has all still left with characters, then we need to do the difference is going to be the second string minus I, second string length minus I, otherwise it is going to be the first string minus I and minus j. Okay. And this will be negative, right? If the first string has become equals to n, the second string, so this would be negative. This is positive. I guess this is our solution. Println difference. Okay, let's check, right, whether we pass all the edge cases. So I guess we have covered them. Let's check. So let's say when we are equal, right, when both of them are equal, so here there is no difference. So what we will do is I and j will start with 0. We'll start by comparing. So this is not equal will never satisfy. We'll keep on increasing I and j and we'll reach the end of both strings. So both of them will increment at end at the same time. And we go over here. Is difference equals to -1? Yes, difference is equals to -1. So we'll enter into this. That means we need to check. If both them are equals to like I is equals to n and j is equals to m, that means both the strings has terminated. We are marking difference equals to 0, which is this case, right? So if I run this, we would be seeing it 0. Okay, print both ij. Let's check, right? So let's check first. Okay, so now it is 0, which is fine. It is coming from here. Okay, what if I add a non-matching character over here somewhere in between? If there is any non-matching character, then it is fine, right? So we'll go over here. This would satisfy, and we'll find out the difference. There is one problem. If the difference becomes equals to -1, difference can be -1 as well. So we can't use difference over here. Instead of that, let's use a flag. Flag is equals to 0, and we can use the flag over here. If this is something where you find difference, we mark the flag as 1. The flag is still equals to 0. That means we never entered this. Okay. Now if I run this, so now we have a mismatching character which will be identified over here. Here we'll check, okay, it is mismatching. Both the strings are of same length. Now what we'll do is we'll find out the mismatching character, we'll find the difference in it, and we'll mark the flag as 1, we'll break. Since the flag is equals to 1, we'll not do anything over here, and we'll print the difference, which is fine, right? E minus L, which is -7, that is fine. If we just do the reverse, we'll get this as positive number. So if I do this and change this to E, we'll get a positive number, which is also fine, right? So these two cases are fine when there is a non-matching character. And even if like you have some difference in length of the string, that is also fine because the non-matching character is present, and we'll just end up with here. We'll not run this if else part, right? Now, if there is no non-matching character and you basically have such a string which is equal, and the only difference is the difference in length of this, there are some additional character over here, and entire thing like this thing matches, right? So basically what you will do is we'll just try to increase I and j. One of them will exhaust, will terminate this loop, will come over here, flag is still 0. Now we'll check if both of them are n and m, that means strings are equal. If they are not n and m, if this is equals to n, first string has exhausted, then the second string is fine. This is should be -4. If the first string is exhausted, then we'll be seeing +4. Okay. Understood? Yeah, so the implementation wise, this is a little bit tricky given these edge cases, right? These are few edge cases that you have to handle separately apart from this initial logic. Okay, understood this? Yes, no doubts? Got it. How many of you have doubts on this? Tell me. Yeah, I know this is tricky. This is a lot of edge cases. That's why at this can I told you, right? Interval will not ask you to implement comparative. This will be a different. This will be a separate question in itself to implement the comparative function, right? Dekho, what? So let me explain you this. So you all know about dictionary order, right? You all have done it. If I give you 2 strings, you will be definitely able to put it in the dictionary order correctly, right? You don't need any you don't need any computer science logic in that. You all have done it since childhood. You have seen dictionary, you know how the dictionary order works. So you all know that. Even if I give you 10 strings, you will be able to figure out the exact correct logic for them, how they will be there in dictionary order. Now, how you do it, you actually just do this. So you just try to locate the first non-matching character if there is no non-matching character. For example, here, all the characters match and there are additional characters. So what you do is you just put this string into the next string. Okay. Here the difference is in this scenario, the comparative function returns the length of this string, right? Length of this non-matching characters, length of this character that is not present over here. So here it returns 4. Okay. So this is one case. And if it is present in the second string, so it would return -4, right? How many additional characters you have, that many number of characters it would return. Achha. If it is equal length, or if it is like, or if there is a non-matching character anywhere, so for example here, it will return you the difference in that. Okay, so that's how you place that. You find out the first non-matching character. Here, if I give you this string and this string, you will always place this string first, even though its length is greater, because this is the non-matching character, and in the dictionary order, this is smaller. Right? So same thing it will do over here. We will compare these 2 strings. You'll check which one of them is like greater, which one of them is smaller. So here you'll say, oh, this is non-matching character. You'll find out the difference. So this returns the difference between that non-matching character. Okay. So now we can use this to implement our function. So how did we implement our function? We wrote 2 iterators I and j, which is traversing through both the strings. Okay. Now I ran through this logic, which is basically finding out the first non-matching character. We find out the difference between them. If we got the difference, then that's fine, right? We mark the flag as 1, we break, we don't need to do anything. If we found out the difference of any character, we don't need to do anything else, right? If there is any non-matching character, found out the difference, done. But if there is no non-matching character here, and we end up like matching all the characters, all of them matched or something, right? All of them matched. Okay. So we'll go over here and we did not find any non-matching here. So we'll check flag is equal to 0. Yes. Now, if both the strings are and both the strings have ended, which is this case, right? If both the strings are equal and you will not find any non-matching characters, they are equal length. So we'll just do this. If they are equal length, then we'll return the difference is 0. Okay. If they are non-equal length, right? Let's say this scenario with the non-equal length, then we'll find out how many non-matching characters are there. How many characters are there in the first string, which is not present in second, or the reverse. How many characters are in the second string, which is not present in first. So in the first, if there are first string is exhausted, second string has character, will return a negative value. If the second string is exhausted and first string has character, will return a positive value. Okay. Done. Okay. You don't need to do ASCII subtraction by storing it in integer and doing that subtraction yourself. The compiler will automatically do this subtraction for you, right, in integer. That is an implicit conversion. It happens automatically. You don't need to do this conversion yourself. Okay. Justified why this should be a explicit interview question, not a similar question like implement the equals or implements the contains function, because this has a lot of edge cases and this is like very tricky to implement, not simple like contains or equals or function. That's why like where you need compare to, you can use that function, but but you always need to know this implementations. Okay, these are very easy, super easy implementations, not difficult. Compare function again has order n complexity, right? Similar C. So it is order n complexity, whichever is the larger string, right? Whichever is the smaller one, I guess. Whichever is the smaller one will run only for the smaller case. So it is order n if and it only runs for the smaller case string, right? Smallest, whichever is the smaller one, that is n. So if the two strings are n and m, so it is big of minimum of n and m. Okay, so it is big of minimum of n and m, where n and m are the length of two strings. Okay, see this loop. If else we can write n minus m. That would also be fine. Yes, instead of checking this, you can just write n minus m. I guess that is also fine. That would do this. That would do this. That's fine. You just remove both the cases and you can do this. Yes, thanks for pointing that out. That looks better. Yeah. Okay, clear? Compare to done. So now I'll see this implementations in sorting. So I'll tell you a very interesting thing about sorting. Okay, sorting is very interesting. Do we have time first of all? We have time, 20 minutes. Pi n minus m. So this is basically the difference, right? If like what does it return? So for example, here if all the characters are equal, so it will be negative positive. That's fine, right? So for this first case, it will be positive. And if these 4 characters are present in the second string, it should be giving negative, right? So if this is the thing, it should be giving negative. So it will be giving negative, right? That's fine. So this also gives us negative and this also gives us positive, right? So that's fine, right? Negative and positive is fine. So in earlier case also, we are explicitly converting it to negative when you are getting the positive result. You can use it, but so I'm not telling you cannot use it. You can use that inbuilt function, but you might get a question like implement this function yourself. So you need to know the implementation. Okay, so you can use them. There is no problem in using them. At times you might get a better complexity without using them. So that point of time, you yourself would feel like writing it yourself. But at times interviewers ask you this. Okay, so these are the questions that you get in interviews. Can you, instead of using this contains function, can you write that logic yourself? Instead of using this substring, can you do something like string concatenation to get this? Because we think that would be better or something. So those places you might need to use this. Substrings or is something which is very bad. Right? So that is very bad. You should not be using it. Replace and replace all also would have a very bad complexity, guessing. My interviewers keep asking. See, if you know this, it would be a very interesting, right? If you like practice this, these are the super easy questions that you'll get in interview, right? So I would any day prefer the interviewer asking me to implement a compare to function than going into something like, let's say, graph or diving deep into that, right? So yeah, so when you'll see more difficult questions, you'll feel like yahi pooch lo. Okay, this would look easy. Collections.sort. No, that is a different sorting algorithm. Chalo, let's talk about sorting now. Okay. So I'll give you one algorithm at least today. We have 20 minutes. I don't need more than that to give you one algorithm on sorting. Okay. So what is sorting? Yes, I'll give you not bubble selection. Chalo, I'll give you selection sorting. Okay. Bubble is little bit would take some time to explain. Selection is easy. Okay, so what is sorting? So we know about arrays, right? So the most important operation in array is sorting. Okay, so this is a very, very common operation that you will need to perform on any kind of array or actual software building. Why? See this. So think of situation. Sorry. Yeah. So think of a situation like you are going to buy something on Amazon, and let's say you filled like you try to perform like a search. You did a search, you get the list of results. Now the first thing you always do is try to apply a filter, right? Filter is basically sort by the rating, sort by the price, sort by the, let's say, manufacturing year or something, that you want to sort them by there are relevance, or sort them by the ratings or customer reviews and so more things, right? So there are so many parameters that's given to you on which you would want to apply a sort on those list of items that you get, right? So every site has some sort search functionality. Now once you get the search result, your first thing is that you perform is to try to sort them, right? You sort them to get the result, to see the result in the sorted order, right? Now this is like very super useful sorting. So firstly we'll just see it for numbers, and then you can think it of like float, decimal. For characters you can think, for strings it is like a little bit tricky, so I'll explain them tomorrow. Okay. Okay, so let's say we have an array of numbers. Take a, let's, for simplicity, let me write the numbers here. Method do in ascending, right? No, there is a way to sort using the methods in descending order as well. Okay. So the easiest way to apply sorting is do arrays dot sort, and you'll get, you can pass a, and then you can print this. So it is array dot sort, not arrays, I guess. Array dot sort. It is arrays. Okay, chalo, it is arrays then. I'm so bad at this names, right? In the interview, I always say, let's assume it is arrays dot sort. I know that interview is not going to run it, so I'll tell, let's assume it is array dot sort, or it might be arrays dot sort. Okay. Okay, so this is sorting it, right? This is sorting it, that's fine, right? We have an inbuilt function. So why this is like 2 classes we had to learn this one line of code? No, actually, right? So similar to any other functions that you are using till now, this is different. Okay, why sorting is different? Because there are hundreds of sorting algorithms that's there. Yes, there are hundreds of sorting algorithms. Okay, now some of them have n square complexity, some have like n cube as well, worse than that. Some have like n log n, right? Some have something some have like in best case it would give you order n, but in worst case it gives you n square. Some have like will give you n log n in best case, but we might give you n square in the worst case as well. So there is combinations like this. Now what is the complexity for this arrays dot sort? This is big O of n log n. This is the most optimal sorting algorithm that you can write or you can implement, which is n log n. We have not found out any optimal sorting than n log n. This is the most optimal sorting we can have. There are a lot of algorithms that we have for sorting. So for example, we have selection sort, right? I'm writing the ones that we will be learning here, right? So you have selection sort, we have bubble sort, this, and we have insertion sort. These are the 3 which is there in this current module itself, insertion sort. After this, later you're going to learn about merge sort, heap sort. Okay, we'll also see about, so we have one more, we'll talk about 4 of them at least, which is, so this is counting or bucket sort. So you have merge, heap. You're also going to learn about quick sort. Right, so you're going to learn about total in 7. Okay. Apart from this, there are even a lot of other sorting algorithms. For example, you have radix sort, you have cyclic sort, you have Tim sort, and you have like even more, right? If you try to Google up, you'll get even more sorting algorithms like this, right? Now, the like most simple question that we have, Some kid has given names, yes. So now most simple, like most simple question that I get always is, okay, sir, why do we have so many? You're telling we have hundreds of sorting algorithms. Is there any need of this 100 sorting algorithms, or we have just created them and we are learning it, right? Is there any practical use of it? Why do we, like, if we have, like, if we know that arrays.sort is n log n, right? We get this is like the best sorting algorithm, right? So why are we learning so many, and what's the use of this? See, sorting is always subjective, right? What's where you want to apply sorting. So I'll give you one simple example. You'll completely understand of what I am telling. Okay. So this is a practical thing, right? Practical story. I'm not making this story up. This is there in even written in a book known as Cracking the Coding Interview. So there was an interview by Google. Okay. So I already told you about, right? Relative hiring, right? I told you that concept where you have to perform better than all the other candidates, then only you'll get selected, right? It doesn't matter how good you are, you have to but perform in that interview. You have to perform better than the other candidates that are appearing for the interview, right? So there was a Google interview, and what Google was doing is, so listen to this story and you'll understand why this is there, right? So this is very important, right, to understand this. Why what's this is not a story, this is like actual interview experience. We'll learn a lot from it. So there was a Google interview, and then there were like a lot of candidates that were being interviewed, right? So interviewer was simply asking one question. He was like telling that let's assume you are given an array of like numbers, and you have to basically apply sorting and get me the list of sorted list. Okay, so give me a sorted array. So every one came in, right? One wrote like merge sort, someone wrote heap sort, someone wrote quick sort, someone wrote radix sort, someone figured out right n log n sort, right? Someone used memory to get n log n, someone used like time, like wrote some logic to get n log n. Everyone wrote a very fancy sorting algorithm to finally get n log n, because everyone knew, right? N log n is the best sorting algorithm. There is nothing better than n log n, so we cannot apply, no matter whatever algorithm we'll apply, we'll get n log n, right? So that is the best one, right? So for example, quicksort has a worst case complexity of n square, but in best average case it gets n log n. So you say in average case it is n log n, but in worst case it goes to n square. Heap sort in all the cases goes to like order so n log n in most of the cases. In worst case it is like it goes to little bit tilts towards order n log n. Sorry, order n square. Merge sort is always n log n, but it uses additional space. Right, so merge sort is always better, but it uses additional space. So there is like pros and cons of every sorting algorithm. So everyone wrote them like they asked, can we use additional space? If interviewer said yes, they wrote merge sort. If they asked, interviewer said no, you cannot use additional space, so they wrote heap sort or quick sort, that which also gets n log n, right? Now okay, so now there was like, so everyone does this, and there was one candidate who walked in. Okay, so interviewer gave the same question, and it was like he would also apply some sorting algorithm like heap, merge, sort, and he would go away. So this did not happen for this particular candidate. What he did was he asked it's one simple question, that what does this number mean, right? So you're telling we have a list of numbers. What does this number mean? It would be something, right? It can be pin code of someone. It can be years. It can be the years from the calendar, right? It can be age of the person. So it would point to something, right? In practical thing, this number should be something. So for example, if you are searching for mobile phones, okay, so and you get a list of mobile phones that's there. So these mobile phones, the list of mobile phones that you're getting, that it has a price, right? And the price is in a range, right? Let's say you applied a filter of let's say 1 to 20,000, 1 to 30,000, 0 to 30,000. So you see the like mobile phone prices varying from 30,000, right? So he simply asked them, what does this number represent, right? There should be some physical thing. There should be something that these numbers are representing. Can be age, can be a pin code, can be a year or something. Then I told, okay, let's assume it's age of people. Okay. Now this is a very important information. Okay. Age of people. Now he told, okay, if this is the age of people, then we can simply apply something like counting this. Okay. So what we can do is, instead of thinking of any sorting algorithm, right? Forget about sorting. So what we can do is, so we can count the age of how many people are there in this. So let's say we'll take an array which is of 125 size. Okay. Assuming the smallest age is 0 or 1 and the largest age is 124, 125. Let's take it for 50. Okay. If you tell that there are people I have seen 130 years of age, let's take 150. Okay. So there is no person who lived more than 130, right? This is the age of people, not age of any animal or not age of any other creature. It is the age of people. It is the age of human beings who generally live from 0 to 100 years. There are few people who live for 100, 116, 115 or 120. Let's say they live for 150 years at max. Okay. Now, can we count the age of each? So how many people are there with age 0 and store it in the A of 0? Right? Can we count how many people are there with age 1 and store them in A of 1? Can we count how many people are there in age 40 and store them in A of 40? How many people are there with age 50 and store them in A of 50? We can store this, right? We can store the count. We can just need to do one traversal of it. And how will this look like? So let's say this is the count. Okay, let's take it count. So what we need to do is we simply need to do this. This is, let's say, traversing. So what we need to do is count of A of I plus plus. A of I is the age of the person. Okay, if you did not get this, think it like this. What's the age of the current person? A of I. So whatever age it is, we can just do count of age plus plus. Okay, let's say this is the array that we got, and this represents the age of person. We finally resulted this. Now at the end, what we can do is we can start a loop from 0 to 150, and we can just check if the count is greater than 0. Okay, we can print that many times. Okay, let me do one thing. This is something I've not applied any sorting algorithm, nothing I've done. Okay, I've just used some count technique that we already know and printed. Okay, for those who do not understand, I'll explain this. But let's see how is it sorting actually. Okay. So why is it printing 2 times? 0, 1, 2, 3, 4, 5, 6. Okay, I we have checked payoff. I is it greater than 0? If it is, then we run from 0 to less than this, or we can run from 1 to equal to this, and we can print I. Okay, is there anything else that I printed? Oh, this is something which I printed. I don't need this. Okay, see, so this is a sorted list, right? 1, 2, 3, 3, 4, 6, 7, 10. Right, so this is the sorted list. We did not apply any sorting. Right, Sasta hashing is back. Acha, have we done this thing earlier? We have done this thing earlier in case of strings. Remember, kuch kara tha aisa ki string mein we counted the character or each character in the string, and then we used it later. So see, the question was simple. So there is no sorting over here, but this is interesting. See, so what we did over here, right? We tried to so let's say we knew that these were the ages. So the maximum age can be 150, right? Let's assume there is a person who is living till 149, 150 years of age. So you assume that this is the total number of people. What we did, we iterated through our current array, and we told what is the age. So A of I is the age. A of I is the age. For I equals to 0, what's the age? 2. For I equals to 1, what's the age? We'll get 6. So what we did when we got 2, we just increased the count at index 2. So count at index 2 by 1. So it increased to 1. Then we got 6. So A of 1 is 6. We increased the count at index 6 at 0, 1, 2. Let's say this is index 6. We increased by 1. Then again, we got count at index 1. Let's increase it by 1. So increase it by 1. Count at index 10. Let's increase it by 1. So increase the count at index 10 by 1. Count at index 7. Let's increase it by 1. Increase it by 1. Okay. So increase the count at all these indexes. 3 was present 2 times. So we increase the count at index 3 2 times. Firstly by 1 and then by 2. Okay. Now what we did, since this array is storing the count of all the ages that we have. Okay. Other cells will be empty. All the other cells which we don't have, so they will be empty. So what we are doing over here is, here basically we are just trying to traverse that thing that we have created. Okay, and we are checking, is the count greater than 0? If it is, then we are printing that many values. So if the count is greater than 0, then let's say this count is equals to 3. So and it is for age, let's say for age 2 we are getting 3, right? Because it is present, let's say 3 times 2, and we also have 2. So what we are doing is we are printing 2 3 times. So we are getting 2 2 and 2. If we have, like, let's say earlier we have 1 1, if we have 2 3s, then we'll print 2 3s. If we have 5 4s, we'll print 4. If we have 1 1 1 4, we'll print 1 4. If we have 1 5, we'll print 1 5. Understood? So this entire thing, what's the complexity of this entire thing? This is nothing but order n. This outer loop is constant, right? But this would run till order n times, right? This would exactly be matching with order n, and this is also order n, right? This is also order n. Why we print count t times? So for example, here in this case, C, so if count of 3 is coming out to be 2, so we have to print 3 2 times, right? In the sorted array, 3 would be appearing 2 times. If you sort this array, we would be printing, we'll be getting 3 2 times, right? So that we have to print 3 as equals to it count numbers, right? So if 3 is present 2 times, we'll be running till the loop till 2 times, and we'll be printing 3 2 times, right? So now understood this, okay? And this is actually a sorting algorithm, right? But there is constants, we cannot use it always. But this sorting algorithm is known as counting sort or bucket sort, which has the best complexity of order n, but this cannot be used always, right? So for example, if you have an array of strings, you cannot use it. If you don't know the range, right? If you don't know the range, or if the range is in negative to positive numbers, it is from negative to positive numbers, or if the numbers are in decimals, right? So all those cases, we can't use this technique to sort. But since the particular case where we were asked to perform sorting was age of people, and this exactly fit in the scenario where we can use age of people to sort it, right? That is so this is like bucket sort. We can call it like bucketing things, right? Bucketing characters, bucketing numbers. 2654, which one? 2634 over here. Okay, see, so what we are doing over here, let's say we got the count of anything that is greater than 0, so we have to print that. But how many times we'll be printing it? So let's say 3 for 3 we get the count as 2, right? So we have to print it 2 times. For example, if the 3 is present, let's say 5 times, so you have to print 3 5 times, right? 3 would be printed in the output result 5 times. So this loop will run for 5 times, and we'll print in each iteration we are just printing 3. Count of 3 is 5, so we are printing it 5 times. Okay, understood? So see, knowing hundreds of sorting algorithms is okay, but always the optimal sorting algorithm is based on the type of values that you have in it. So sometimes, if given the kind of array you would get, you might get a better result using insertion sort than using a merge sort, right? Sometimes using a merge sort, you might require too much space. Merge sort would be too much space consuming, so you might need to use a quick sort, even though its worst case complexity is order n square, right? But in average case, it would give you n log n. So sorting is always subjecting depending on what are the values that is present over here. So if you are already having a string of array which is very space consuming, you cannot apply a merge sort, because that would result in even more additional space, and that is problem for us, right? If we have a very long string array, we would avoid using merge sort, because that would consume more memory, right? So that for memory wise, it is very bad. We might use a quick sort, but in worst case, it would give it an n square complexity, which we might be fine with if it has like using merge sort is going to overflow memory. So this is bucket sort is not going to work, right? So let's say let's say the array of number has negative values. Is your bucket sort going to work? See this? So you cannot have a negative index, right? In the count, you cannot have a negative index. So this is the case where it fails. If your array is a decimal number, which is a lot of arrays, right? So your price array is a decimal number, your ratings are decimals, right? So a lot of arrays are in decimal numbers, 4.5, 4.3, 5.2, the ratings are in decimal numbers. So you cannot apply a merge sort there. Sorry, cannot apply a counting sort there. If for decimal, float, double, for negative numbers, it breaks, right? For strings as well, you cannot have a string index, right? For a string array, you cannot have a string index. So this cannot be applied everywhere. So I gave you the constants where it would be failing, where you can't use this. If the numbers are negative, you can't use this. For negative numbers, for strings, for decimal numbers, You cannot use this, right? Cannot use counting. Or if you don't know the range, okay, so you can say, we can debate that, we can find out the range from range using minimum and maximum. But even if you figure out the range, let's say the array stores values like in order of 10 to the power 14, 10 to the power 18. Will you be able to create a count array that stores whose index can be 10 to the power 14? What's the largest size array that you can create? So the array's largest size can be 10 to the power 6. You cannot 10 to the power 5, 6, roughly that range, right? 10 to the power 6 would be the maximum that would be allowed, right? 10 to the power 7, 8, 9, 10, 14, forget about that, right? So if the numbers is very large, right? Array values are very large. So you cannot create array like that. Right? You will not be able to create a very large index array, right? So that won't be possible. So you'll not be able to use counting sort. See, so we have so many scenarios which cannot be covered by counting sort. So we need other sorting algorithms, right? But that guy, since he gave this answer, he was selected. He thought through the question. So sorting always is a like, I would always say that it is a subjective question depending on what is the data stored in array. So if you ever get a sorting question in interview, okay, so don't think like it is my lucky day and interview is very happy and it is asking me, he's just asking me to write the best sorting algorithm. I know merge sort, heap sort. I know so many n-log and sorting algorithm. I'll write any one of them. No, you need to ask good questions there. And what is a very good question to ask, that what does this data represent? Is it years on years of the calendar? It is the years till date, right? The years that we have been till date. Is it like the age of people, right? Or is it like if it is a positive or negative number, is there any range that we know of, right? Is it a pin code, right? If it is a pin code, then what is like this number? Is it always a 6-digit number or is it varying 6-digit numbers, right? Is it mobile numbers of people, right? So you would immediately know that it is always a 10-digit number or something, right? So is there any information that you can ask and interviewers would give you, right? Since you are asking information, he would tell you. If he says no, assume that it is a random set of numbers, right? Positive, negative, anything it can be, something like that, then you can decide on the sorting algorithm. But you should always ask that question before writing the logic, okay? Because it's not always your lucky day. It's interviewers who is trying to trick you, right? It completely depends how much you can be tricked in that interview or how much you can be careful there, right? What else we do if it is a pin code or something? So let's say if it is a pin code which can be 6-digit. So pin codes are generally in order, right? There is a starting pin code and there is an ending pin code. So you always have a range of that, right? So it's a 6-digit number. So but you always have a range. So let's say India follows a 6-digit pin code convention. So all the pin codes are 6 digits, but the starting range is, let's say, like the starting pin code, the very first pin code, it would be somewhere kahin to hoga India mein, which is 00001. ऐसा कुछ होगा, ठीक है? And then at the and the ending pin code would be something like let's say 99999. So this would be the range, right? These are all the pin codes that exist if it is a 6-digit number, right? So you get some information, right? Bucket sort, yes, 6-digit might work, right? Bucket sort might work for here. So you might get a bucket sort working over here. Yes. If the list contains all the pin codes, then the best thing is to implement bucket sort. You will need additional number 6 space, but that is fine, right? And you can even optimize it since you don't have a okay, you have 1, 2, 3, that would also be there. Okay. You can think of that pin code or something. If it is year, then you know, right? If it is years, then you know that there are only 2000. We are in 2023, so there are only 2023 years that has elapsed from 0 to this, right? Excluding years are not in BC, right? So that's fine. Okay. So any sort of information like years, age, date, number of days of a month or something that would help you to figure out this, right? Or if it is not at all anything of this, you can choose the best algorithm among these, right? So you can pick the best one among these simply instead of just applying a blind thing like let's go for merge sort or let's go for heap sort or let's go for bubble sort. Okay, instead of doing a blind logic, you have some context. This would be better in this case, right? They have to remember, so they are not difficult. They are not at all difficult. They are super easy, right? Very easy to remember. None of them are difficult. Okay, so you don't need to actually remember them. You will be easily able to understand them. If you understand it, you can remember it. Should we write the logic or should we start with it tomorrow? I'm just thinking. Will it overflow or should we start tomorrow? So you're already over time. So let's discuss this logics tomorrow. Okay, so all the three logics will discuss tomorrow. Okay, so these three will discuss tomorrow. Okay, counting. So I already gave you the logic. So this is the entire logic of counting sort. Very simple. You already know, right? I see you even given the name to this logic, which is Sasta hash. I think I kind of like that name. So we actually, this is not actually hashing, but you can say counting using array or something. You can give a better name like that.
Sir,
Yes. That's it.
can I ask one thing?
Yeah, sure. Say.
If you have taken a range, the array size is 150, and if you do not know the range, like in case of edges, it can be maximum 100 or 150. But if we do not know the range, like what it can be the maximum. So
Yeah, so for in that case, we'll like, so for example, let's say we ask this question and we say that assume that it's a negative positive numbers, right? It doesn't different essentially anything. It can be a negative and positive numbers. So we can ask, is there any range of this negative positive numbers, right? If there is no information about this number, they don't represent anything. They are just random numbers. So is there any range of these numbers? He says, let's assume they are like at max, the number value is going to be 1000 or something. So for every question in the constants as well, so not just given the length of array, you are also given this, right? So in the questions, you don't get the length of n, you also get something like this. So the array is from, let's say, -100 to a of I is less than 100. Aisa kuch bhi diya rehta, right? See, in the constants also, this is also mentioned. So basically, you're trying to get this information from the interview. If let's say he says, the numbers are from -100 to +100, then you got the answer, right? So you have, even though you have negative numbers, you can store, let's say, these negative numbers you can store in index 101 to, let's say, 100 to 200, right? So first 0 to 100 represents the positive numbers, and then this represents the negative number or something like that. You can somehow store them in a 200 size array, right? You don't need more than 200 indexes. Or let's say he directly says that the arrays are very random numbers. It is in the range of 10 minus 10 to the power 18 to plus 10 to the power 18. So you would know that, right? There is no way to apply counting sort in it. So we can then go for any one of these sorting algorithms or like this sorting algorithm or something. Then you can ask questions like, are we allowed to use additional space? Are we not? If he says no, we are not allowed to use additional space. These are very large array. So additional space is going to be very big problem. So merge sort is ruled out. We cannot do merge sort. Heap sort is also heap sort and quick sort can be choices. So we get some idea, some information of where things can be heading, what interviewer is trying to ask. Okay. Okay, got it. So you won't even get like every time ऐसा नहीं होगा कि ideally AG बोल दिया interviewer ने, but you will get to reach to at least filter down something that you can do. Why most of them have n log n? Why don't we use sort if constants are high? So constants are high, but this uses additional space. This is like you can think it like merge sort, little bit optimized. Okay, so this is like a merge sort with a little bit optimization. So this uses additional space. Now, if we don't want to use additional space, we might need to write quick on heap sort. And this is also a custom sort that is written. This is not actually a merge sort. This is known as dim sort, which is created using merge and insertion sort. So like there is a lot of possibilities that we can do depending on data. Okay, so it's basically varying on requirement. So we need to know how this works. Okay, very easy algorithms, right? You won't even find it difficult to remember them. Max array length can go up to, so ideally on the compilers it's 10 to the power 6, but it like in some compilers supports 10 to the power 7, 8 at max, right? So 10 to the power 6 is something which all the compilers go to, and you like they would expect you to use 10 to the power 6, not greater than that. Will you require for sorting? Only one. We require only one. These three are the only ones we are going to learn. That I just wanted to share this one, which is easy. Okay. These three will just require one class to cover all the three algorithms. Very easy algorithms. Okay, very easy. You already know about array, so there is nothing new. You know how swap works in array, how we change them. So only one class I require to complete this. Okay. Okay. And this is not there in this module altogether. These all things will, these are not even there in anywhere. This is there in the later parts of the module. Interviews won't say you ever to use a given sorting algorithm to sort it. The point is not to check whether you know a sorting algorithm. The point is to check whether you can figure out what's the best way to sort it. Okay. So whatever can be the best ways, so we would give you all the variations of it. So you can use at least one of them to be like to fit your case. Is sorting the last pass? Yes, yes. So tomorrow ideally we'll complete all the theoretical concept and then we'll just spend time on doing questions. Okay, so for today, complete your string questions. अच्छा array list वाला question आज भी रह गया है. Shit, sorry. ठीक है, we'll discuss it tomorrow. So array list में question is there, right? You want me to discuss triplet sum to x. ठीक है, that one I'll discuss. I've given also one question on
Pascal's triangle, sir.
Pascal triangle. ठीक है, so Pascal's triangles we'll discuss. Okay, so tomorrow we'll do sorting and then we'll discuss questions itself, right? So Saturday revision we'll try to do questions. Okay, and this week you might not. This week's your contest will not, I guess, have this. नहीं होना चाहिए ideally. Should not be sorting. Should not be there this week. But I'll check whether it is there or not. Okay, because you don't have any 2D arrays till now. You've not given, so I'll expect that to be there. No, we have to solve a lot of questions, right? We have just seen the surface, right? So we'll solve sorting. We'll solve a few questions. Okay, try to complete the strings one at least. Today we did all the string parts. So now all the things that's remaining in string, complete them. Okay, and try to do questions from Jim. If you feel like starting on sorting, I don't think you will be starting with. Okay, let's tomorrow we'll discuss them and then you can start sorting algorithms. But till then, right, if you have completed everything, you just have doubts, so you can use the Jim, right? So Jim is there always. Now you'll be getting more time to solve Jim questions. Okay, since this is the last assignment that's there. Okay. Well done. Okay.
Hello, sir.
Yes. Yes.
मुझे चीज पूछना था सर, डाउट है थोड़ा स्ट्रिंग के बारे में सर. मान लीजिए सर, मैंने इनिशियलाइज किया स्ट्रिंग s इक्वल टू हेलो and then string s2 equal to s. Then sir मेरा string constant pool में जब मैंने string s equal to hello किया तब string constant pool में तो मेरा hello store हुआ, ठीक है, और s2 भी उसी hello को point कर रहा है.
हाँ, s2 उसी को point कर रहा है. तो यहाँ पे जावा ना थोड़ा कैशिंग कर देता है. क्या करता है कि अगर वो स्ट्रिंग ऑलरेडी प्रेजेंट है कांस्टेंट पूल में और हम दोबारा उसको s2 में पॉइंट करें समथिंग, तो s2 को उसी रेफरेंस में पॉइंट कर देगा. बट ये फर्स्ट इंस्टेंस के लिए ही करता है. बट अगर आप इसके बाद करोगे ना s2 इक्वल्स टू वर्ल्ड और समथिंग, s2 को अपडेट करोगे, सो इमीडिएटली क्या करेगा, एक नया स्ट्रिंग बनाएगा, बस चेंज करेगा,
s2 को रेफर करेगा. हाँ. और सर अगर मैं ऐसा करूँ कि दोनों न्यू कीवर्ड से दो स्ट्रिंग बनाऊं, तब तो अलग अलग स्टोर होगा.
तो दोनों अलग है, तब तो दोनों हीप में.
तो वो क्या सर हीप में स्टोर होगा या और स्ट्रिंग कांस्टेंट पूल में स्टोर होगा?
एक्चुअली इनिशियली वो हीप में स्टोर होता है, बट एक कीवर्ड है जिसको यूज करके हम उसको चेंज कर सकते हैं स्ट्रिंग कांस्टेंट पूल में.
लेकिन सर अपना से क्या जाता है स्ट्रिंग कांस्टेंट पूल में?
नहीं, अपने से हीप में जाएगा. अपने से तो क्रिएट करेगा. ओके,
न्यू कीवर्ड से करेंगे तो हीप में जाएगा, ठीक है. और अगर मान लीजिए सर और एक केस है सर, कि स्ट्रिंग s इक्वल टू न्यू स्ट्रिंग, न्यू से मैंने एक स्ट्रिंग किया, ठीक है, स्ट्रिंग का नाम दिया s, और मैंने सेकंड टाइम किया स्ट्रिंग s2 इक्वल टू s, तो सर कि वो क्या हीप में बनाया स्ट्रिंग को इंडिकेट करेगा?
तो फिर से रिपीट करूं. पहला में हमने s1 बनाया न्यू स्ट्रिंग यूज करके एंड देन s2 इक्वल्स टू s करा, राइट?
हाँ.
तो हाँ, वो हीप वाले को पॉइंट करेगा और यहाँ पे वो पॉइंटर हीप वाले स्ट्रिंग पे ही पॉइंट कर रहा है, ठीक है.
उसके लिए तो इस कंडीशन में तो स्ट्रिंग कांस्टेंट पूल में पॉइंट नहीं कर रहा है.
नहीं कर रहा, वो सेम स्ट्रिंग को पॉइंट कर रहा है. बट अगर आप इसके बाद अपडेट कर दोगे ना, s2 इक्वल्स टू समथिंग लिख दोगे, तो जैसे s2 इक्वल्स टू हेलो या समथिंग लिख दो, तो फिर अब वो स्ट्रिंग कांस्टेंट पूल में वापस चला जाएगा और वहां पे पॉइंट करने लग जाएगा. सो बेसिकली अपडेशन का कॉन्सेप्ट ही नहीं है. स्ट्रिंग अपडेट ही नहीं करता. वो कहीं पे भी स्टोर हो, हीप में स्टोर हो या फिर वो पूल स्ट्रिंग कांस्टेंट पूल में स्टोर हो, वो अगर आप जैसे अपडेशन या रीअसाइनमेंट लिखते हो तो नया स्ट्रिंग बना लेता है इमीडिएटली.
Okay, okay, ठीक, got it.
Any more doubts? So I pasted the link in chat. We will be also seeing it along with the recording. Okay. Any more doubts? Okay. Anything new in string goes to, yes, anything using new will always go to heap. There is a keyword, I guess, entry is the keyword to override it. So you like using that, you can move it to the string constant pool, but initially it always goes to the heap. Okay. Thank you, everyone. See you all tomorrow. Right. Complete all the questions. Percent भूल गया. ठीक है, चलो percent I'll discuss tomorrow. ठीक है, percent I'll discuss tomorrow. That's interesting. That's another. Try to implement the percent yourselves. Right. I gave you the entire logic. You know ASCII. You know number manipulation. I don't think that would be difficult to implement. Done. Easy, right? Just check the first character whether it is like find out that digit corresponding into it. If you get the digit, you can easily form the numbers, right? Digit into 10 plus t. Hello, try to do that. We'll, if not, then we'll explain it. Okay. Hello, for others, we'll discuss if you have doubts on that. Thank you, everyone. See you all tomorrow. Bye-bye. Good night.